All right, good morning, everyone. I hope you are well and welcome to this webinar. This is the second year of us running this webinar after a successful hosting of last year's event. The webinar this year is entitled Evolving with Technology, and we are glad that we have received a good response with over 250 attendees who have RSVP'd for this event. Our audience is diverse, and the majority of our audience is from South Africa, and we have presentations that will be covering diverse areas. We also have participants or attendees that are from our neighboring countries such as Zimbabwe, Swaziland, as well as Botswana, and some of the more international countries such as South America, Brazil, Uruguay, Europe, Sweden, Finland, just to mention a few, as well as the United States of America. The participants that we have as part of our audience are part of diverse occupations, and we have foresters, silviculture specialists, academics, silvicultural specialists that are focusing on research, consultants, machine manufacturers, as well as students. Our hope is that through this webinar, you'll be able to discover and learn from local and international experiences. You'll be able to exchange information through our question and answer sessions, and we'll be able to build relationships as well as connections through this process. So to kick off, without wasting any further time, I would like to introduce Mrs. Melissa Pico, who is the head of marketing at the George campus. Ms. Pico is going to be standing in on behalf of Dr. Kaluke Mawila, who is our campus principal, who unfortunately cannot make it today. However, we are in good hands, and I'm going to hand over to Melissa to do the opening and welcome address. Over to you, Melissa.
Good morning. Thank you very much, Modrani. Good morning, ladies and gentlemen. It is an honor and a privilege to be part of the conversation this morning. Ladies and gentlemen, as Modrani has introduced me, I'm Melissa Pico, Head of Communication and Marketing on the George campus. And as a campus, we are honored to host a webinar of this magnitude. This morning, I wish to share with you greetings and a message from our campus principal, Dr. Kaluke Mawila. She sends her most sincere apologies for not being able to join us this morning. However, she has assured me and, assured the colleagues as well that she will catch up with the conversation and that she is honored, to that once again as a campus, we are hosting this webinar. Allow me, ladies and gentlemen, to please share a message that she has shared with me this morning to share with the rest of the congregation. It reads as follows. Greeting, ladies and gentlemen. Kindly accept my most sincere apologies for not being able to join you this morning at this momentous congregation. I'm honored once again to have an opportunity to address this conference via my colleague Melissa. This time I address you not only as the Nelson Mandela George Campus Principal, but also as the newly installed chairperson of the Forestry 21 Advisory Board. We have an opportunity to do incredible game-changing projects to arrest, respond, and to create sustainable solutions for the future of forests in the world. At the heart of the work we ought to focus on is the generation of new knowledge, which enables applied transdisciplinary solutions to persistent human survival challenges. As you are aware, more than 1 billion people depend on forests for their livelihood, for the air we breathe, and for sustaining our communities. So as you are aware, more than 1 billion people depend on forests for their livelihood, for the air we breathe, and for sustaining our communities socially, economically, and culturally. The relationship between humans and forests is at the heart of our existence, for it is not only the use, care, of and the regrowth of forests that we must meet to contemplate, but it is also the cultural impact that forests have on our collective memory that we must grapple with. I am sure that all of us grew up listening to folk centers around humans and the forests that We rest our critical, moral, and ethical educational foundation on the precepts articulated in the narrative of folklore, even before we learn to read and write. We have an opportunity to enhance our forestry curricula in ways that develop a new generation of emerging professionals in forestry. A cohort of foresters who are acutely attuned to the challenges of communities and can lead, investigate, design, implement, and create new solutions in partnerships with industry. It is my hope that as we deliberate on this conference, we remember to engage our students as active co-creators and beneficiaries of the programs, projects, products that will emerge from the various teachings, research, and knowledge diffusion processes. Our mission as Nelson Mandela University is to be a university in service to society. As such, we take pride in actively participating in the research and transformative practices that will emerge from these conference deliberations. We have confidence that our university curriculum, teaching and learning pedagogical approaches, and efforts of advancing science for society will pay off. I therefore once again thank you, and on behalf of Forestry 21 partners for the stellar work that you guys are doing. Thank you so much, and I trust that you will have a successful webinar. Thank you, ladies and gentlemen.
Thank you, Melissa, for welcoming us and for just setting the scene in terms of the university's perspective. We are looking forward to this webinar, and just to start off, I'm just going to talk briefly about the theme that we have chosen for this year's webinar. So both locally and globally, we continue to see many efforts to modernize silvicultural operations. And these efforts are continually being driven by the need to reduce costs and improve productivity within silvicultural activities. Not only is there a keen interest in improving productivity as well as reducing cost, but there is also thorough investigations into what is the impact of all these new technologies on the growth of the trees, the survival of the trees, as well as the uniformity of the trees that we grow. We do understand that the fourth industrial revolution is amongst us, and despite the challenges that we have faced with the pandemic, we have seen new silviculture technologies introduced into the market, and there are currently several new developments that are in the pipeline. Whether these new technologies that are in the pipeline will eventually be adopted and used is yet to be seen. However, what is positive is that we can see that there is a process taking place wherein new technologies are being developed, and hopefully they will be adopted and can be able to improve the way in which we do things. Our theme of evolving with technology basically focuses on how we have gradually been developing and finding new and innovative ways to practice silviculture. Even though in South Africa, most of our silvicultural activities are still predominantly performed manually, we've also been taking steps towards modernizing some of the activities within our nurseries, soil preparation, the planting process, as well as tending. So today we are going to listen to 7 presentations, 4 local from within South Africa and 3 international presentations. And these presenters have voluntarily agreed to share their knowledge as well as experiences, and I'm hoping that we can all benefit from what they will share. The local presentations will focus on presenting interesting developments within our nurseries, as well as how residue management is being applied through a practice of mulching, how planting activities have been developing over time, and the issue of ergonomics. As we are developing and introducing all these new technologies, we need to understand what are the economical implications of these activities and systems that we are introducing. Furthermore, for us to remain abreast with what is happening, not only in South Africa, but internationally, we will also have presentations that will touch on silviculture developments which have taken place within Sweden and Brazil, as well as some of the new technologies in terms of using drones coming from Uruguay. So please take note of the following, that we are going to have our first session. The program is displayed on your screen as we speak, wherein we are going to have 4 local presentations, and then we will take a 15-minute break and then resume and complete the remaining presentations, which will focus more on an international perspective. We do have the questions and answer session that has been scheduled for once the local presentations are complete. So please use the chat area to be able to put your questions there. And then during our questions and answers as well as discussion session, I will then pose the relevant questions to the appropriate speaker who will then respond. We are at the mercy of technology. So if we do experience any technical glitches because of various reasons, please bear with us, and we will take every effort to ensure that it is resolved. We have had several dry runs prior to this, so we are hoping that things can run as smoothly as possible. So before each presenter speaks, I will introduce them by going through the basic and very short resume, which introduces and tells us about the presenter. Then I will hand over to the relevant presenter. The webinar is being recorded, so upon your request, we will then be able to share a recording of the webinar as well once complete. So without wasting any further time, let's get into our program. And I'm going to start off by introducing to you Heinz Reinsdorf, and he is going to be presenting on the topic of integrating new technologies from nursery to field, a look at what's happening around the world. But just a bit about Heinz is that Heinz was born in 1968 in Stellenbosch and grew up in Pretoria, where he attended his primary and high school. He returned to his town of birth to study BSc Forestry and completed his honors in 1992. So he's currently based in George and working from his home office. And if we look at Heinz's work experience, he's got a lot of experience, and he started his career at Mulches and Hobbies in 1993, assisting with the development of the company's environmental policy. And in 1994, Heinz started the position as nurseries manager for the 3 clonal nurseries, HL and H, which was operating in Tzaneen, White River, and Eshowe. At the time, the company was one of the leaders in eucalyptus clonal forestry in South Africa, and it worked closely with Brazilian companies like Aracruz. An opportunity to work on a greenfields project in the Malaysian side of Borneo Island came across his table in 1996, and Heinz applied to Borneo Pulp and Paper for the job as a nursery manager and moved across in August of that year. The 3-year contract involved planning, setting up a clonal nursery with the capacity to meet the company's planting targets of 25,000 hectares a year. At the end of 1999, Heinz moved back to South Africa and was offered the position as a forest nursery specialist at the Swedish company BCC AB, which he joined early 2000. His job has taken him across continents, visiting projects in 35 countries during the past 21 years. Heinz assists customers with the planning and designing of new nurseries, upgrading of old nurseries to new and appropriate technology, as well as expansion projects where clients need to increase their seedling capacities. Assistance is also provided to customers who need help with propagation of forest seedlings. Heinz also runs his own company, Forest Nursery Systems, on the side for private forestry nursery consulting jobs when time allows. If we look at briefly Heinz's personal interest, he enjoys mountain biking, water skiing, and wakeboarding, kayaking, and a bit of fishing. And with him having young children, he's back into doing some tennis and kicking a rugby ball as well as soccer ball when he's got the opportunity. without wasting any further time, I would like to introduce Heinz. Heinz, we're looking forward to your presentation, and please go ahead.
Good morning. Thank you very much, Modani. Thanks for the opportunity. And yeah, good morning, ladies and gentlemen. I'm going to take you through a little bit of a road trip, if I can call it that. Looking at different examples around the world of what's happening. I'm focusing probably more on the nursery side, but how we integrate with planting in field. There are guys that know more about planting systems and planting technologies and the development of that, but I'd like to touch on that and see how we can make the nursery actually dovetail better with in-field planting. So yeah, Modani gave a nice start there, so I'll just get going straight into it. Just for those who don't know, I assume that you can see the presentation. Modani, all is okay, right?
Yes, I can see it. Thanks.
Right. So BCC is a family-owned business started in '87 by Hans Björkemar. He still owns the company together with the rest of his family. Our head office is in Landskrona, southern part of Sweden. We have about 48 employees, and we work through a network of dealers, agents, representatives around the world. We've done projects in approximately 65 countries during the last 30 plus years, and currently active, I would say, probably in about 30 countries. The range, the brands and the equipment range of BCC, on the right hand side there you can see the different brands, BCC itself, which is the conventional production equipment and trays, etc. The seed center equipment, FiberCell, which is the latest development of BCC, I would say, in terms of degradable paper growing systems. Coniflex is a system that's used in Scandinavia, Europe, the Baltics, and that is for the protection of seedlings against the pine weevil up there. And then the Potiputki range of equipment, of planting equipment and carriage equipment. So I would like to start with Sweden, just to show an example of how nurseries are packing their seedlings and then how it's handled out to the field. I'm using an example of this company. It's called Svenska Skogsplanter. They're probably one of the biggest growers in Sweden, and they use different packing systems. In this case, in this specific nursery, they use what they call the Coniflex and automatic packing line. So here the Coniflex system applies Hydrofix glue to the seedlings and then covers it with sand, and that gives a physical barrier so that these pine weevils can't chew through the bark after planting. Just to mention that seedlings that are not protected or that are not treated and are planted out in the field have up to about 80% mortality. So it's absolutely crucial to protect seedlings. And since these Nordic countries are not allowed to spray anymore, they need another solution. So this is a solution that's been developed together with the Forest Research Institute of Sweden. So the productivity here is about 5 boxes per minute. They pack about 100 seedlings per box. And these boxes also feature a rip cord, so that you can actually use this box as a carrying. This just shows the line itself. So just to jump to the next slide here, these guys are using big warehouses, cold storage warehouses to keep their seedlings in. In this case, this is a new development of 7,000 plus square meters. This holds 42 million plants. So they overwinter their plants for planting in spring. So all plants produced in the summer are then packed in autumn and overwintering in cold storage facilities like this. So this is the inside of this warehouse. You can see stacking racks, and they're also using shuttles to be able to get to move these pallets in and out of these these shelving units. This seedlings are stored at -4 degrees Celsius, and that keeps them dormant. And then they are using, this company uses a logistic company to handle all of this for them. So they do all the storage and the handling of the plants. They also do the transport out to the field. Here you can see this is the shipping rack, so that's standardized. So these pallets get loaded onto a shipping rack and then out to the field. So that makes it just the handling so much more efficient. These are the different cold storage units across Sweden. So they've become less but bigger. That's been the trend lately, is to have larger units of storage facilities throughout Sweden. This just shows the trucks with semi-trailers. So they piggyback a forklift on that, so it's easier to offload at site. And semi-trailers also allow for a bit more flexibility. They can offload right at the customer's GPS position, so that's all communicated to the transport company, to the logistics company. And obviously using optimizing communications allows for better time usage and saves money. Yeah, you can see the boxes being offloaded in field, and they also protecting these boxes against frost and heat, sun, and covering them with like aluminium foil cloth before they get opened and planted. So this is typically how plants are planted and handled in field. Two methods. One is the box. As I said, it's the box functions as a carrier as well. So you can rip. There's a rip cord in there, so you open it up, and that can go onto a carrier system, which you can see on the right bottom corner here. So those boxes can be carried, but also in many cases, these planting boxes, these kidney planting boxes, are used for planting out in the field. So in Sweden, they plant about 400 million plants annually, seedlings, and 90% of containerized seedlings in Sweden are planted using the Poti-Putki planting system. And they reckon approximately 3% is planted mechanically. The average productivity in Sweden is about 2 to 2,500 plants per person per day using the Poti-Putki system. So the next country that we're looking at is Finland. This shows also packing lines that they are using. They're packing into open crates, the specific nursery. This is Stora Enso, one of their first packing lines. And here you can see the crate that they pack into. So the predetermined number of seedlings that go into these crates, they get loaded on shelves, and these shelves get or these racks get then transported, loaded onto trucks and transported to the field. This is the latest technology of Stora Enso. Excuse me, I just want to hang on a second for me, please. All right, so this shows the latest technology of planting, packing lines, developed in partnership between BCC and Stora Enso. So I'm going to show a short video, but I'm just going to jump through it a bit. I don't want to show everything, just to show the concept of how this works. Here, the plants are not actually packed into a box, but the box is actually folded around the plants. So as you can see, everything is controlled from a mobile device, the complete packing line. Then from there, here you can see the sequence of plants moved into the box position, and then the box actually gets folded around the plants. So it's a different kind of concept. It follows sort of the Stora Enso method of packaging. And I'm just going to jump through a little bit here. So these plants are then collected and the box is then closed off. All right, the video is a bit long, but just to give you the idea as to how that works. And that allows for higher capacity. It also allows for the plants to be better handled. Yeah, as you can see, 6 to 7 boxes per minute. And they fit depending on the size of the plant, but with 50cc plugs, which is quite common up in the northern part of Scandinavia, they can fit up to 140 plants per box in a standard box like this. So planting in Finland, they plant around 160 million seedlings a year, 96% of containerized seedlings also using the Poti system. 4% of these plants are planted, of these containerized are planted mechanically, and similar productivities then they achieve in Sweden. Just coming down to Brazil, seedlings are normally packed in the nursery, graded and selected in the nursery. There has been some development in terms of more modernized packing, I think with February, but I'm not sure if we have someone from Brazil talking about this today. I don't have anything on that, but I would say that this is probably still the most standard system used, where plants are packed in lug boxes and then transported to the field. Kept next to compartments, protected, and in cases where trays are being used, these plants are then removed from the tray on roadside and packed into lug boxes. As I said, there's also semi-mechanical and mechanical planting systems being introduced in Brazil that we've seen, but I'm sure there will be someone that will talk about that. So just going through to Chile, this shows one of the Arauco nurseries with a multi-level manual packing line. This specific one has got 24 workstations and productivities here up to about 9,000 plants that get packed per person per day. They do random checks for quality control that gets scanned by barcode reader. And barcodes are then also being used on the actual planting buckets that go out to the field that contains all the information. Here you can see about 80 to 100 plants are packed per crate. These are then stacked and bulked up to about 500,000 stock per day at this specific nursery before it gets shipped out to the field. A little novel idea with the crates here. They can stack on top of each other. If you turn them the one way, if you turn them the other way, they nest into each other. They've started using palletizing of these crates, of the plastic crates. Just makes it much easier to load, much faster to load trucks, instead of using the manual system of loading trucks. And this is a typical planting box, holds up to about 80 plants, and this is used for infield planting, and the majority of infield planting is still done manually in Chile, as I understand. Looking at Argentina, here they use that system of rolling, basically a rock and ball method, where they roll the plants in plastic, close them up in a plastic sheet. And they achieve they roll them up to about 54 seedlings per bundle, and doing between 7,000 and 8,000 per person per day. So, but the problem here, what they have said is that if roots are not consolidated properly, as you can see the trays that they grow them in normal trays with inserts, these root plugs do get damaged during transport. So they do about 128 bundles per trolley, a trolley like this, and these trolleys get loaded directly onto trucks, and they can do about four trolleys in a truck, gives you about 30,000 seedlings per truck. So infield issues that they have with this is plastic waste, how to handle that. They have to get rid of the plastic waste. They have a limited time from delivery to planting because of drying out, disease, root bridging. Can't keep the plants in there for too long. And they also need to repack into planting buckets. So the overall labor is quite intensive for this packing system. As you can see, these are the planting buckets that are used typically in Argentina. They are carried in these planting crates using plant spades, and average productivity about 1 hectare per person per day, depending on the species planted, anything between 1,100 and 1,250. and mostly done in hilly terrain. On the right-hand side, you can see the mechanical planting system used can take either 1 or 2 persons. And it's that unit which has been developed down in South America, I believe. They do about 5 hectares with a unit like this per day, but has to be flat terrain and also well-prepared sites. Just quickly looking at the US, this just shows 2 different methods of packing plants. On the left-hand side here is a trailer which has been customized for quality control and selection and then packing. And then on the right-hand side, a typical packing station. These guys also plant, or they pack mostly into boxes, which then go out to the field for planting. Australia uses both boxes and trays to ship their seedlings out from the nursery to the field, and they also typically use these carrier systems and planting spades to plant with. Although potiputki has also become quite common and popular planting system in Australia. See more of those being sold. Jumping over to Indonesia, plants are typically manually packed and graded in the nursery, also into crates, but also in the trays itself. So depending on the nursery, depending on the customer, and for transporting and in-field handling, these trays normally get treated before they're sent out to the field. Rudimentary protection on roadside, and then before plants are being removed and placed into crates before planting. So here you can see the planting buckets used. Also a planting tube type of growing system or planting system that's used. In Indonesia, the productivity is about 3 units per hectare, and but that also includes making 2 additional holes for fertilizers. So soils are also not as friable in Indonesia, so probably a little bit more difficult than in Scandinavia. They do trial mechanized planting systems right now. We will get to those a bit later, their discussion. This shows Malaysia. Typically, plants are sent out by truck in trays, and again, very rudimentary protection out in the field. Sarawak, if anyone knows Sarawak, it looks like an egg box. The topography, it's very up and down. These guys use very simple carrying systems, bags. They use a sunduck or a very simple planting spade to plant, and they achieve about 2 to 5 units per hectare with a system. Just looking at China, this again is Stora Enso. They typically pack into plant boxes or crates in the nursery. These crates are then sent out to the field, and this is a system that they developed themselves, attaching it to a gel dosage system that they attach to the potiputki planting tubes. And these guys then, with these knapsacks, they then apply gel during the planting. Just looking at Russia, this is a typical setup of modern Russian nurseries. Packing line, multi-level packing line, also packed into boxes, and they then place these onto Euro pallets, which also get stored in cold storage, similar to Scandinavia. And these pallets are then sent to terminals and distribution points, where boxes are then loaded on smaller vehicles for taking out to the field. And they also use both potiputki tubes and also simple planting dowels. So in flat terrain, they also use tractor-mounted planting systems. So just to look at current and future mechanization in nurseries, to actually dovetail with planting systems out in the field. This shows a typical multi-cup sorting and grading line. And this is to do the actual quality control before plants get then packed into boxes. And just to quickly show you how this basically works, how the tray gets unloaded. This shows a vegetable nursery, but we'll use the same principle we'll be using forestry. So seedlings are placed out of the tray into a special cup. These cups are then going through a, just find that one, these cups are then going through a visual system, camera system, where they measure different parameters, quality parameters of the seedling. They then get sorted, as you can see here, in a sorting station. So after the sorting of these plants, they get sorted each different quality sorts, and after sorting, these plants are then placed back into the tray. So this is something control, and we will probably see this probably in the near future in nurseries. Here we're looking at about 60,000 plants per day that a line like this can do. This is a new type of system that we are looking at for packing plants from the tray, then after the grading and sorting, to pack those seedlings then into an open crate, like a lug box. So, and here we reckon about 6 trays per minute can be done. And this unit probably requires 1 to 2 persons just to load the trays and to unload them. So just to look at mechanized planting, I'm not going to say too much about that, but what I would like to say is that, yeah, these have, as many of you know, these have been introduced into South Africa, South America, Southeast Asia, in some cases still being trialed. For instance, Southeast Asia, achieving around 1.7 hectares per day. There was an article in for Silviculture showing the three head bracket unit here, achieving 900 seedlings per hour. And just a couple of factors for consideration, especially if we look at nurseries and how we integrate with these machines is just to look at seedling count for the size of the machine, seedling volumes for the area. Those are kind of things that we need to discuss, that we need to keep in mind when we think about new technology from nursery to mechanized planting. Also, in terms of the seedling form, the straightness of the seedling is important. We have seen problems with seedlings that are not straight to be planted with these machines. Logistics, how to get the seedlings to the machine, in terms of carrying capacity of the machine. Also looking at the replenishment of these carousels and of these cassettes, how can that be done in the best possible way? So couple of issues that have been picked up also in places like Southeast Asia is the access to compartments, how fast you can move the machine between compartments, the terrain itself, row alignment in terms of the slope, and here they specifically mentioned that they had to do up and down slope planting. And in places like Indonesia, labor is still a cheaper option. So, and then of course slash management, very important. And just the last slide to link up to that mechanized planting is and that is something that we are looking at and busy with at the moment. We can't share too much at the moment, but all I can say is that dovetailing nurseries and infield planting, especially mechanical planting, requires an efficient and effective solution. Getting the seedling from the nursery, as we see on the left, all the way to the planting hole. And this obviously involves the complete supply chain, packing in the nursery, transport to the field, in-field handling, and then linking up with a mechanical planter in the best possible way. And that's something that we're working on right now, and we will probably have something by early next year, first quarter of next year. We should have something to present to this group again. So thanks very much. Thank you, Mutani.
Thanks, Heinz, for that presentation. Quite comprehensive, and it gives a good outline of exactly what is happening both internationally and locally, and how we can integrate some of the necessary activities to how we then plant in field. So I'm sure there will be some questions, and you'll be able to take those, and we will deal with that during the Q&A session.
Yes, I haven't spoken specifically about South Africa because I know there are guys that can talk about South Africa, so I'll leave it to them.
All right, no, that's fine. That's fine.
Right.
Thanks, Heinz.
All right.
We are now going to move along and we are going to have a presentation by Lishan Mahadeo. And Lishan will be presenting on the topic of improving mechanized reestablishment efficiencies through mulching. So just briefly about Lishan. He says, I'm intensely passionate about working in any environment closely associated with nature, hence my chosen field of study. My childhood has encompassed a strong agricultural ethos, and my family has been associated with the maintenance and management of orchards and vegetable crops for decades. My experience with agricultural aspects was primarily for substance during my childhood. However, with much determination, it's evolved, hence allowing me much exposure, ease, and comfort in terms of my field. Lishan has got a BSc in forestry from the University of Stellenbosch, and he is currently busy with his MSc. He began in 2020, and he is an MSc student with forest operations at the Stellenbosch University. And in terms of experience, Lishan has worked as a junior nursery manager at Enseleni Nurseries. He has also been a student forester at Siakubeka Forests, and he has also worked as a forestry assistant at Singisi Forest Products. His interests and hobbies are traveling and gaining exposure in one of his favorite areas of interest. He also enjoys socializing, hosting guests, and cooking, and especially to see the satisfaction of everyone's face after he has prepared a good meal for them. He also has a passion of volunteering at the Verulam Frail and daycare homes where he is able to assist those that are disadvantaged. Thank you, Lishan. We're looking forward to your presentation on mulching, and I'm sure it will be of much benefit as this is still a new and a new area that we are not well aware of. Over to you, Lishan.
Thank you, Mudani. Really appreciate it. Thank you for the opportunity for actually presenting to you. So as you know, my name is Lishan Mahadho, and today I'll be speaking to you on improving mechanized reestablishment efficiency through mulching. Just a brief overview on my presentation and the topics that we'll be actually touching on. What is mulching? So mulching is an application of organic layer over a soil surface. And in forestry, mulching offers a solution for communication of residue almost immediately after harvesting. And some benefits amongst others, the reduction in period between harvesting and reestablishment. Also reducing fire risk by eliminating or reducing the fuel load content and providing long-term soil health. And this is done by providing nutrients and maintaining soil moisture. So the aim of the study was to quantify productivity rates, CO2 emissions and costs between eucalyptus and pine plantations. And in addition, we were able to analyze the influence that residue management, which is burning versus mulching, on pitting and planting productivity. Looking and diving deeply into the time studies of these operations, understanding the biomass before and after mulching, and also monitoring fuel consumptions of these operations. There were two research sites that we looked at. The first was at the low-lying Zululand area based on sandy soils at the eucalyptus site, and then the high elevation Bulwer plantation where we looked at the pine stands on clay-rich soils. Just a brief description on the sites that we actually looked at, the stand size as well as what was previously species planted, as well as the machine that we use for mulching both at the eucalyptus and pine compartments. So the mulching specifications, here we see a Tiger Cat 58C mulcher equipped with the FAE 300U mulching head that was used at the Zululand area on eucalyptus. And then we have the Tiger Cat M726G mulcher that was used at the Bulwer pine plantation. Both of these mulches are horizontal drum mulches and were powered by 350 horsepower motor, and they were considered highly comparable. So understanding the biomass before mulching, so we have looked at the stump volume, where we took the average stump volume and scaled it up per hectare value on both eucalyptus and pine compartments. Then using the line intercept method, we were able to estimate the residue volume on eucalyptus and pine. And then combining both the stump and volume method, we had a total above ground biomass. We looked at the eucalyptus at 48.5 cubic meters per hectare, and then in pine 112.9 cubic meters per hectare. You note that the pine is quite high due to the compartment experiencing a snow and fire damage during its lifetime. Just a visual illustration of the pine plantation up at the Bulwer area before mulching and after mulching. So moving on to the mulches productivities, we see that in the eucalyptus compartment study site, we see a mean of 0.38 hectares per hour, and in pine 0.35 hectares per hour. So understanding how many hours it takes per hectare, we see that it takes around 2.78 hectares per hour in eucalyptus and 2.90 hours per hectare in pine. To standardize both of these results, we looked at minutes per 100 meter. So in the pine, we see a mean, or in the eucalyptus, we see a mean of 4.13 minutes per 100 meters. And in pine, we see 4.06 minutes per 100 meters. Just some comments on the productivity. So we see that both mulching achieved similar productivities in both treatments, pines and eucalyptus, such as 0.35 and 0.38. And even though that the initial biomass values were quite high in the pine compared to the eucalyptus. And this makes us indicate that these machines are had adequate mechanical capacity for these tasks and wasn't hindered by any of these biomass. So moving on to the CO2 emissions. When we talk about CO2 emissions, we directly link ourselves with fuel consumption. So we have, with supplementary data, looked at the fuel consumptions of these machines and see that in the eucalyptus, it took around 32 liters per hour, and in pine, 34 liters per hour. Using the productivity of the machine, we then scaled it up per liters per hectare, and using the diesel up to 2.7 kilograms of carbon per liter of diesel that was that were emitted, we're able to get the carbon emissions per hectare. So looking at the eucalyptus site, we see 240.2 kilograms of carbon per hectare, and in pine 266.2 kilograms of carbon per hectare. Looking at the costs, getting the machines cost on both eucalyptus and pine, and then using the EU-based cost action model to then predict the cost of rands per hectare. So you see in the eucalyptus, it costs around 5,393 rands per hectare, and then in the pine 6,126 rands per hectare. Discussing this on all these, both on the costs, the prices, and as well as the CO2 emissions, we then want to understand what's this whole part all about. So mulching productivities between eucalyptus and pine stand did not differ significantly. We did see a 26 kilograms of carbon per hectare difference in emissions in pine and eucalyptus stands, and mulching costs both on eucalyptus and pine stands were comparable. Even though pine costs around about 733 rands more per hectare compared to eucalyptus mulching, this difference in these costs were directly related to the machine's fuel consumption as well as the machine's initial purchase price, and not the difference between species. Moving on to the second part, where we looked at the productivity of downstream operations. Here it's the visual illustration of the Zululand area, where we were privileged to go back after 6 months to view the growth difference. So the pitting productivity at the Zululand area, or based on eucalyptus, was based on the mechanized impact pitter, and then at the pine we were able to observe for manually based on a pick. So looking at the site at eucalyptus, we noted that pitting after a mulch site provided about 15% more in productivity, and in the pine site, pitting after burning provided 10% increase in productivity. Planting productivities in the eucalyptus site, we based it on a semi-mechanized planter, and in the pine site, we were available to only analyze on manual planting. We then noticed that planting after mulching increased productivity by 50%, and in the pine site, planting after mulching also increased it by around 40%, the productivity in the specific areas. So looking at the results, we noted that the higher productivity rate was observed for pitting after mulching compared to burning on a eucalyptus site based on the mechanized pitting. And then looking at the opposite had happened at the pine plantations, where we saw that the productivity rate observed for pitting was quite high after burning than pitting after mulching, and that was based on a manual pitter. As expected, both mechanized and manual planting productivity after mulching was higher in a mulch site compared to a burn site, which was resulted due to fewer impediments. Moving on to the conclusions on these things. So manual pitting is slightly quicker on burn site compared to mulch site, and both semi-mechanized and manual planting were both quicker on mulch sites. To just draw attention on what we have noted was that incomplete combustion of large materials negatively impact movements of machines and persons on a burn site, and if we used windrowing, we could actually get the complete combustion of these materials. Overall, mulching combined with mechanized pitting and semi-mechanized planting yield the highest productivity. Thank you for your time, and I'd like to acknowledge my funders, York Timber and Sappies, as well as Bruce Talbot and Simon Ackermans. Also the mulching contractor, Civiti Group, Mr. Dion Ridringer. Thank you for your time.
Well, thank you, Lishan, for that interesting presentation. Yes, mulching is an important and interesting part, and it's quite important that we are starting to get some data which can then be used for decision making, which is relatively accurate. And I think well done on this work, and we're looking forward to it getting published through your MSc and also getting published in some of our scientific journals. Moving on, we are then going to have a presentation by Nonkululeko Ntinga, and she is going to be presenting on quantifying the economic benefits of modernized operations. Now, she's going to look at the relationship between ergonomics as well as productivity as well. Just a little bit on Nonku. Nonku is an operational research specialist at Mondi, South Africa, and she holds a diploma from the Nelson Mandela University in forestry. She also holds a BSc degree in forestry and wood science from the Stellenbosch University. Over and above this, she also has a certificate in economics from Rhodes University, and she is currently completing her MSc in human kinetics and economics at the Rhodes University. She's one of the few individuals in the forestry sector focusing on economics with great interest in fatigue management, and building on this, a master's research topic is aimed at understanding the issue of fatigue in long-haul drivers. So we are looking forward to Nonku's presentation, which is going to be looking at the important issue of economics. Nonku, over to you.
My name is Nonkululeko Ntinga, and I'm Mondi's Operations Research Specialist, focusing mainly on our productivity database and also on the interesting parts of ergonomics. So today, I'm overview of how has Mondi used ergonomics as part of the modernization, modernization journey. So basically what I'll take you through is a bit of a one-on-one on what is ergonomics, etc., and looking at ergonomics interventions that have been applied as part of the modernization system, looking at benefits at ergonomics that Mondi has reaped, and also looking at a bit of an ergonomics in design. So a paper written by McEwen and Steenkamp in 2014 stated that there were four main drivers towards modernization, and this is illustrated in a bit of a pillars, and I like to call these the pillars of modernization. The first one being a drive towards safer operations, so a safety drive. There's also an ergonomics drive, which I'll go into detail as part of this presentation, and there was a productivity. There's also a productivity drive in terms of increasing the productivity that's achieved as part of our silvicultural activities. And also in 2014, there was a big concern with regards to the availability of reliable manual labor in our operations. So what is ergonomics? I think everyone uses the word ergonomics in the operations, that the operation has improved ergonomics. But what do we mean as part of that? Ergonomics is a scientific discipline concerned with the understanding of the interaction among humans and other elements of a system. It is a profession that applies theories, principles, data, and methods to design in order to optimize human well-being and overall system performance. The two main things that I'd like to highlight as part of this definition supplied by the International Ergonomics Association is that, firstly, ergonomics is about the understanding the interaction among humans and other elements of the work system, meaning that it has a human-centered approach and looking at all the other systems that affect the way we do our work. An example is that as we're sitting here in our watching this webinar, we are actually also working in a system. You are sitting in a chair, you are in a certain climate as part of your webinar, and you are also, as a human, trying to understand and trying to grasp the information that is shared as part of this presentations. But then there's an aim, or there's a benefit as part of ergonomics. The first one being optimizing human well-being. And I mean, obviously, as having a human-centered approach, human well-being will also be the main aim of it. We're trying to reduce the aches and pains that people are feeling when they leave work. And also, we were all working in a business system. The overall system performance must work better once by applying ergonomics. And those are the main two goals of ergonomics. So just to zoom into the whole aim of optimizing human well-being and also system performance, I like to use this illustration. So when you are working in a system, there are two main things that are almost balancing according to each other, and this is according to ergonomics. The first one is task demands. There are demands as part of the task. There's something that needs to be that's something that needs to be achieved at the end of the task. And then at the other end of the scale, we have our human capabilities, because all tasks are carried out by someone, and they have certain capabilities. Some, as part of, if you're a lecturer, you have qualifications. Some have physical capabilities. If you are if you are working in field, you need to have certain physical characteristics or capabilities in order to complete a certain task. But what happens when we work in this system, or we try balance these two systems in order to achieve optimal ergonomics? What happens is that when there's a match, so this is when the human capabilities match the task demands. For example, we have someone working in field pitting. They have certain capabilities. They are physically fit, they are strong, they are healthy, etc., and are able to carry out the pitting system or the activity of pitting. When there's a good match, there's an increase in productivity and there's an increase in worker well-being. But at times, we have certain times when work the workload is very high, and it results to the human capabilities not being matched to the task demands, and it results to a decrease in productivity and a decrease in worker well-being. So there are three main domains of ergonomics, and I'll just give a brief overview of these domains. The first domain is physical ergonomics. This is concerned with the human anthropometrical, physiological, and biomechanical characteristics in relation to physical activity. So this is mainly has to do with the physical aches and pains, the musculoskeletal disorders, the physical way of doing work. And a lot of, and forestry being quite a big manually intensive operation, we found that physical ergonomics are very, they're being applied a lot. And then the second one is cognitive ergonomics. This is concerned with the mental processing, such as perception, memory, reasoning, and mental motor responses. So this has to do with your mental capacity and the brain. And as we're sitting here listening to the webinar, we're all activating our cognitive ergonomics. We're taking information from the environment, processing it, and making decisions as part of it. And then the last one is organizational ergonomics, which is with the optimization of social technical systems, including the organizational structures, policies, and processes. This is things like shift design come into play as part of organizational ergonomics, and it has to do with all processes, how well are processes put in place in order for work to be carried out. So, as I've said, physical ergonomics are quite dominant in the forestry sector, being a manually intense sector. And now what happens is that what we do is that we do an assessment of the task or an activity, and we highlight ergonomics risk factors. And what are these risk factors that we are that are prominent? First one being working in awkward postures, then repetitive motions, pushing and pulling carrying of heavy loads, heavy, frequent, or awkward lifting, vibrations, high impact forces, and fatigue. So as part of our modernization journey, what we've done is that we've looked at the number of tasks or operations that take place in part of our Silviculture, and we've highlighted these ergonomics risk factors, put in place interventions in order to reduce these highlighted risk factors. So when I talk about interventions, what do I mean? Well, a number of interventions can be applied in order to reduce ergonomics risk, and this is similar to our safety risk applications or safety risk assessments, etc. And the main hierarchy of controls or interventions that can be applied include engineering controls, administrative controls, and PPE. And I think I want to highlight here is that we always think that engineering controls are the one and all that we have to apply. We have to engineer out some sort of ergonomics risk, but there are also administrative controls. In cases where the budget, you don't have much money to apply, there's administrative controls such as doing training and awareness of ergonomics, and also implementing programs such as stretching and etc. And that allows the person carrying out the job to be aware of the task and to be aware of how can they adjust the way they work in order to make themselves safe and also in order to make themselves comfortable. So I just want to take this hierarchy or the the interventions that I've put in place and show you a diagram or show you a process on how we've applied them as part of the modernization process. So the first one, using pitting as an example. As you can see, this is manual pitting that was carried out. The main risk factors or the main ergonomics risk factors that take place in or that are highlighted as part of this is there's a lot of repetitive shoulder movement. There's a lot of awkward lower back postures, and that may result to musculoskeletal disorders. And as part of that, what we've done is that we've introduced augers as in order to reduce these repetitive shoulder movements and awkward lower back postures. But we need to understand is that by putting in place an engineering control or a certain control, it doesn't completely eliminate the risk factor, but it does at times introduce a new risk factor. And in this case, we've introduced an awkward lifting and carrying risk factor. From the auger being heavy, the operator now needs to lift and carry it while walking in field. So further continuous improvement in that case, we've introduced the impact. But now we always think, oh, all is good, there's no physical ergonomics risk. But we need to understand what has happened now is that the operator is now doing a static work posture. So they're sitting in a cab, listening into his Ecology FM or some radio FM, but he's in a static work posture, but there's a lot of cognitive ergonomics or cognitive fatigue that the operator is experiencing here. So what we can see is that we've moved from a very big physically demanding work task to now a cognitively demanding work task. And that's the one thing I'd like to reiterate as part of the modernization journey. It doesn't mean that since we have gone through modernization and we've reduced ergonomics risk as much as possible, we have no more ergonomics risk in our operations. But there's still the cognitive factor that we still need to reduce as much as possible in terms of fatigue, training and education on how to reduce fatigue and etc. in operations. So the second example is the planting. So we'll see we've had a lot of manual planting where the lady stoops and etc. while planting, and this results in awkward lower back postures. There's awkward wrist posture, as you can see, as she's pouring the gel into the pit, and there's also heavy lifting while she's lifting the bucket as she walks between pits, or he or she walks in between pits. So there was an engineering intervention in there, and there has been knapsack planting. Now the operator or the lady or the guy carries knapsacks on his or her back, and carries a planting tube. But what we need to understand there is that as much as we've reduced the great ergonomics risk from lower back posture and the wrist postures and the heavy lifting, we've introduced prolonged walking with heavy weights on their backs, which means we still have a bit of ergonomics risk. And in this case, we can put in place some administrative interventions, such as stretching, such as taking breaks, etc. Then what we've done, and a further intervention or ergonomics intervention, is through introducing the semi-mechanized planting, where you have a team working behind a boom or a planter. But we need to understand, as much as the weight has been put into or taken away from compared to the the manual planting, but we've had now prolonged walking with no weight on the back, but at the pace of a machine. Now we need to put in place a lot of fatigue strategies in order to ensure that our operators or the team that's working behind the boom is not fatigued while they're working. So here's another example of quite a physically demanding task, and the interventions being put in place, which has resulted in a cognitively and a physically demanding task. The reason why I say this both is that we have an operator or a driver that's now in a cab and in a static motion, but we still have a team that's working behind the tractor, meaning that there's still a bit of a physical demanding in the task. So another example of measuring or quantifying the workload of work, with the workload, and this is a way that we highlight the ergonomics, or we try determine what effect the ergonomics intervention has on the operation. And this is various auger systems that we've researched and looked at. And you'll see there's the BT45, BT130, and the Vasa and the mechanical hoe. And what we found there is that here we were trying to test the administrative side of ergonomics. So looking at what would happen, or what happens to the workload when we put a two-man system. So now we're putting in place fatigue management strategies in order to reduce the workload. So what we can see is that what we can highlight is that once you have two people operating the BT130, the workload reduces from very heavy to moderate. And I must highlight, this is basically just using the heart rate monitoring and also some ergonomics assessments, etc., of the operator as part of the study. So this is just to highlight examples of applying administrative controls in order to reduce ergonomics risk or workload to the person. So, I mean, we always ask ourselves, you're probably asking yourself, yes, okay, if I were to apply ergonomics into my organization, or if I were to apply ergonomics into my work system, the way I work, what happens? So there's a couple of advantages or benefits that one can get from applying ergonomics. The first one being the risk of work-related musculoskeletal disorders. I like to call these the aches and pains of work. There's less aches and pains because now you're working comfortably compared to sweating it out, inverted commas. Then the next is quality of work. Because you are comfortable and now you are concentrating, you are able to make decisions, proper decisions, your quality of work improves. And I mean, I've got a picture there of a planting operation where the operators, once they're working at a comfortable pace and they're working at a comfortable equipment, they're able to plant properly, because you don't get a point when end of the day now the planters are now planting shallow plants. Then there's also a reduced safety risk and also an increase in productivity. So just to demonstrate, as part of the modernization journey, how Mondi has gained an increase, or has reaped the benefits of ergonomics. So in 2012, as part of the ergonomics journey, we had almost 70% of work which is classified as ergonomically challenging, and this is through a lot of assessments that were done on the work that was carried out. But we found ourselves that we had about 69 recordable cases, which was quite bad, because it means we were sending people home hurt and not safely. And then what we found is that last year, well, 2020, we've had almost about an 88% reduction in the safety or the total recordable cases. And this is due to reducing the amount of challenging work, but also there's a big organizational drive towards safety, and those are part of some of the benefits that we have reaped from putting together ergonomic strategies or interventions in order to reduce ergonomics risk as far as possible. So this shows that at Mondi we're now sending a lot of people home safely after work, which is a great benefit. So lastly, I just want to touch on ergonomics and design. And this is quite a big topic, because at times we procure equipment and you get in field. I mean, you look at it online and you think it's amazing and you want to procure it. And once you get in field, you find maybe at times the knapsack doesn't fit your average worker or your average employee. And why is that case? Well, there's papers written in terms of what is the benefits on incorporating ergonomics as part of your design. And when I talk about ergonomics, factors that are put in place as part of the initial stages of design is that we look at things like task demands, understanding the task demands, understanding the human capabilities, and then also understanding the human anthropometrics. What size is the average South African should be in order for us to build equipment that is for the employees that are for the purpose that it's going to be used, and for the employees that are going to use the equipment. So this is just a graph showing the black line being just the methods where ergonomics is not put in place or ergonomics is not consulted as part of the design stage. And the black line, the dotted line, looking at strategies that are put in place or design that are put in place that incorporate design, that incorporate ergonomics. And we can see that there's quite a big difference between the traditional design compared to the ergonomics integrated designs. And this is basically the cost associated with it is high as part of the traditional design. And we find that there's productivity loss, there's service costs, there's quality costs, there's time value, and the lost time hours and compensation costs. So this is just for the designers out there. You know, it's very, very good to incorporate your ergonomics designs or ergonomics as part of your designs in order for you to reap the benefits of incorporating it. So in conclusion, I think as part of this presentation, we've shown that ergonomics practices take a human-centered approach. So the person is at the center of it. We're looking at optimizing human well-being, but at the same time, optimizing best practices or ensuring that there's overall system, good overall system performance. And a number of interventions have been applied as part of the modernization journey, focused at reducing the whole physical ergonomics risk that are from manually intensive operations. But we need to understand that due to the number of engineering interventions, modernized silviculture is now highly cognitively demanding. And now topics such as fatigue management are becoming very important. And also topics such as how do we design the cab to ensure that the driver is able to operate efficiently and doesn't get confused that there's a red button here. What is this red button for? But also lastly is that there are cost benefits associated with including ergonomics at the design stage of your product development. And that's what I'd like to advertise, or I'd like to tell everyone, all the designers out there, in terms of it's good, get to know your anthropometric, who are you designing it for, and what are the task demands that are incorporated as part of it. Thank you very much.
Thanks, Nonku, for the interesting presentation that you shared. It gives us a holistic view of the impact of ergonomics on various activities and sort of where we are going towards with the new developments that we are now seeing. So we are now going to progress, and we are going to have a presentation by Lwandile Mbono. And he is going to be presenting on how planting operations are evolving, a forester's view. Just a bit of background on Lwandile is Lwandile Mbono is from Mzimkhulu, and he comes from an agriculture family background with a granddad having worked as an extension officer. And he also has his own small holding of a subsistence farm. And as a result, he has love and passion for livestock. He's also married to Yanga Mbono, and they have 4 kids. He graduated from Sarsfield with a national diploma in forestry in 2008, and then in 2012, he completed part of his BTech part-time in forestry as well. Immediately after his studies, he was employed by Mondi as a silviculture forester in Babanango, where he spent 3 years. Then he moved to Zululand Coast at the Mondi Mfolozi area. In 2014, he joined Siakubeka Forest as a silviculture forester. Then he was later promoted to a senior silviculture forester until now. In his spare time, he enjoys watching sports on TV and keeping fit at the gym. And he also enjoys spending time with his family, either just having a braai or traveling when he has the time off and during school holidays. So we are looking forward to your presentation, Lwandile. And as indicated, it's a forester view, so we expect a practical and applicable view from your side. Thanks, and over to you, Lwandile.
Good morning, ladies and gentlemen. I think Modan has given quite a nice background and introduction. My name is Lwandile, a forester at Siakubeka. With today's topic, it keeps on jumping off. with today's topic, what I will cover with the, with the evolution of planting operation from a forester's perspective, I will cover just a bit of background as to when did we venture into modernization. I'll then also give a bit of background, dwell deep into the actual planting operations that one has been exposed to, and look at the productivity of modernization and comparisons thereof. Then at the end of the presentation, I'll look at the modernization learning. Next slide, please, Modern. Something is happening. I don't know whether it's my network or so. Okay, as a background to this modernization with the business, I think we saw with Nunku, she gave a bit of a glimpse of that. It started in 2012, where we had a series of trials that were carried out in the business. Through the process, there were a lot of learnings, and some of the systems that we looked at, they didn't actually make the cut, because of either complexity. But at the end of the day, we were able, that was the start of where we at the moment in terms of modernization. Some of the answers we were trying some of the questions we were trying to answer with modernization was the issue of ergonomics and safety risk, as outlined nicely by Ununku with the last presentation. And part of that was also an element of decent work. The ergonomics and safety talk to decent work, but incorporated in the decent work aspect, we will also talk of decent pay. Then the other thing was the issue of inconsistent quality challenges in the execution of operation. With manual operations, your span of control is quite big. You'd find sometimes the quality is not consistent, and many a time you'll end up with low survival and recording. There is also an element of productivity improvements, of which that was covered quite nicely by Modani on his introduction to today's business. We've seen a lot of improvements in terms of of productivity. Those were some of the questions that the business was trying to answer with modernization. Coupled with that is the issue of cost containment. For every business to survive and to stay longer in business, you need to be cost effective, and therefore your cost containment is one of the focus areas that one needs to look at. Then one other thing that one has been noting with interest, and I've been part of the industry for like 13 years now, if I exclude my practical years. Over the years, I've noted the trend that in terms of the staff labor makeup, the people, they are quite old. You're not getting so much interest from the younger generation to come and participate in this hard labor industry, forestry, whereby people, they're not paying so much interest or attention into this. So those were some of the issues that the business actually looked at. Next slide, Madam. Okay. Now, looking at the actual operations now that we are running and under the umbrella modernization, we've got pit and plant operations, of which it was the very first step towards modernization. Some of the activities that we looked at, looking at the pitting, we will know that pitting is quite an intense operation, and it's demanding physically. The very first unit that was, that we saw working is the MPET pitting machine. And the system pit and plant operations, it consists of two individual operations. It's the pitting machine, and then you also have your planting team following behind it. So hence I refer to two individual operations. Both systems, they depend on driving into the compartment. You can't run them on a roadside system. And we have not reached a stage whereby you will say comfortably we can run a drone and it works plant and all that. We're not there yet. It works best with gel. With this pitch and plant system, you definitely need the use of gel so that you can be able to see results with improved quality and as well as a better survival. With this system, also what we sort of enjoy is the reduced span of control, and effectively it gives you a better handle in terms of supervision. The quality of supervision has improved, and effectively that is actually, and that also adds to the improved quality of results at the end of the day. One thing that is of concern with the operation and being drive into compartment, it has slope limitations as well as reduced frequency of incidents. Another positive that we sort of enjoy with this kind of system. Next slide, Mudan. It says video. It's just a small clip, guys, showing how the gel planter works. It's a group of guys that follow. I mean, it's a team of 6 people behind the planting machine. We've got 6 tubes, and the guy, I mean, the team is supported by additional 4 people. Some they supply plants, and then you've got one person that is working on the sorting station, who will ensure they bring in the right quality and into the compartment. Next slide, Madam. Looking at this operation now in terms of benefits and challenges, the pitch and plant, it covers the element of ergonomics and safety risk quite nicely, because the biggest weight, which is your water, is carried by the actual planting unit, and the number of plants carried by an individual, because they carry a bucket on the side of the, I mean, on their hip side. An individual is comfortable to carry that operation without having being trained at the end of the day, of which ergonomics we are covered in that particular space. Quality of pitching is consistent, and effectively it results to an improved planting quality as well, and it gives the plant a better chance to survive. We've noted reduced, specifically in the Zululand area, we've noted quite reduced number, I mean, the percentage of blanking. Before that, when we were in the manual stage, you would never get to a compartment and blank below 10%. But now you do get a situation whereby you are able to measure around 2-3% blanking percentages, of which is quite a big benefit for the business. With the gel in use, it helps to retain moisture for a longer period, especially on your drier period times of the year. You are able to get that improvement of benefit. Looking at the challenges now, what are the biggest challenges when it comes to this feed and plant operation? The harvesting residue, it slows down your productivity quite a lot, as well as the accessibility for the machine. Sometimes you find out your machines are not able to drive into the compartment because of the harvesting residue, if it hasn't been managed through banning or mulching as an option. Slope limitations, being a drive into compartment with battery with low limitation. Cost of pitching, it's a challenge. We've sort of seen improvements with the other operations that I will talk through, whereby we're no longer doing pitching. But this cost, it becomes a sort of a challenge nowadays in the cost of pitching. Looking at the operation now, with that system that we looked at, the gel planter, you are able to get between the 700 millimeters of gel up to 1 liter, which is enough for a plant to survive. In terms of productivity, you're looking at just over 6 hectares, which is 6.1 hectares per shift, or 6.5 productive machine hours. Next slide, Modani.
Lonely, they just said a comment for sound. Maybe if you can move closer to the mic so that they can hear clearly.
Okay. Then the next operation that one will talk to, it's actually split into two, but all that we categorize it under pitless planting, of which you can also refer to it as a single pass operation, because you do a combination of pitting and planting at the same time. With a single pass planting operation, it's also a drive into compartment operation, but we also have an option or an alternative to work on the roadside. You can run your operation or activities on the roadside. Looking at the very first picture, on the very first picture, where you've got a team following behind a tractor trailer unit, those guys are on an operation which is a drive into compartment operation. So they follow behind the tractor. This requires access. This requires, the guys, they need to ensure that, it's a team made up of 6, also supported by 3 people, as well as the sorting person on the roadside. Then the second picture of which is also a tractor trailer unit. This operation or activity we run on the roadside, of which we've sort of made a modification to add on 3 hoses, which are 100 meters long, and with the 3 hoses, on each hose reel that you take out, at the end it tees off, and then you have 2 planters on each hose reel. You end up with two planters on each hose reel, and that allows you to operate from roadside, of which you don't need to drive into the compartment. This helps us in situations whereby you've got slope limitations, whereby you've got access control, access challenges made as a result of harvest residue, or else the compartment hasn't been disturbed. Then the other operation at the bottom, it's a person following behind a tractor. This individual at the bottom is the guy doing the fast trap, of which we'll talk in detail as to what the fast trap is. But the operation is also a pitless planting operation. With this kind of operation, especially the Vasa Planter, we do not use gel for planting operation. There is the reduced span of control, which results to improved supervision. There's reduced frequency of incidents as well, which obviously as a result of the reduced span of control, it also helps, it comes in handy with that. Then there's also less disturbance around the planting area. As compared to pitting, this kind of activity, what then happens, because you only drill or disturb the area where you're going to be inserting the plant, the area around your plant or root plug is very minimal, which is disturbed. And that allows to retain moisture longer, and also it reduces the risk of air pockets, that which may result into mortality at a later stage. Next slide, please. Okay. In this particular section, I'm now looking at fast trap, because you will recall I said the pitless planting, we've got 2 systems. It's the fast trap as well as the Vasa Planter. Fast Wrap, it works with gel. The guys, they also follow behind a tractor trailer unit. Then the only difference now this time around, the guys, they are able to sort of, they use the planting tube to make a planting pit through pressure. You have to insert down insert your planting tube down into the ground, and that allows it to penetrate. What we've done in this particular operation, we've made a modification on the planting bit. We've reinforced it to ensure that it's able to handle the pressure from the ground, but also to highlight as well is that this operation is only possible in the Zululand area, of which is where I operate, because of the sandy soils, obviously. So it works best in that particular situation. With the first picture, you will see a person has just inserted their planting tube into the ground, of which they use the Beck to make that, to penetrate the ground. The second picture, a person then selects a plant and insert it into the planting tube. Once you've inserted the plant into the tube, then it's only then that you can release the planting bell. Before you can actually take out slightly lift up your planting tube and to ensure that the plant doesn't actually float out of the planting area. Once you've taken out your planting area, you then firm up the ground around, the area around the plant, so that you can take, there's no air pocket and the plant is firmly into the ground, put into the ground. Next slide, please. Then we look into the fast wrap analysis in terms of benefits. It combines multiple operations. Your pitting and planting operation is included there. There's less disturbance when making the pit around the planting area or around your planting tube root plug. There's minimal area which is disturbed, and it then leads to improved survival and better chance for a plant to make it. It's a cost-saving exercise operation. Simply because you don't have to pit, you don't have to pay. The cost of pitting is eliminated. It takes a bit longer compared to your gel planter to use this method to plant. But looking at the productivity that we get around 4.5 hectares per shift of 6.5 productive machine hours. Then also the amount of gel, it's the same amount as what you get from your gel planting, because the system is the same. The only difference with this one, you do not apply, pre-plant, pre-pit before the planting operation. In terms of the challenges, it's the harvesting residue, soil texture, hard areas. You cannot, where you've got hard structured soil, you cannot deploy this kind of operation. Slope limitation is an issue because it's a drive into compartment operation. Obstacles on the ground, they may be an issue if you've got rust, which talks to your soil texture as well. They may be a problem as well with this kind of activity. Next slide, please. The next stop is the Vasa Planter, which is still a pitless planting operation. But the only difference now with the previous one is that with this system, it mainly uses water only. It is a high pressure system of which it works. With this high pressure system, it works with a piston pump that allows you, that allows the planting tube to generate, through the system of the water, the planting tube is able to drill itself into the ground, and from there you are then able to make a planting area for your plants, of which the pitting area is shown or reflected by the very first picture. On the second picture is the guy then selects the plant. Once your planting tube has gone into the ground, you then need to move your planting tube backwards and forward and sideways, and that allows the water to sink into the planting hole. And then you insert your plant once you've done that activity. Then slightly you have to lift up your planting tube and firm around the plant. Obviously, you have to be cautious to ensure that you do not damage the plant while firming up the ground, as well as think of the root plant, so that you can avoid the issue of day rotting. With this kind of system, also just to add on the technical side, the type of tractor that you deploy, you have to make sure that it's one of the modern technologies in terms of the hydraulic system, because it works off the hydraulic system. Your tractor must ensure that it's got you need to ensure that your tractor has got a what do you call, a good gear ratio, as well as a crawler gear as well. So those are some of the things or tricks that one needs to look at when venturing into this particular operation. Next slide, please. Okay, this is just a video showing the actual activity. You will see the guys moving from one spot, planting spot to the next. They are basic. With this video, one was just trying to show and reflect how the operation how the operation runs. You'll see the guys moving from one slot to the next. And they don't need fitting the machine or the system built itself into the ground. Next slide, please. Okay, looking at the benefits now of this system. The system combines two operations as well, planting and pitting. It uses water, and it doesn't. The system uses purely just water, and it works best for us in the zone land area. There's less disturbance on the pit area. It's a cost-saving exercise. This system is quite productive, and at the same time, you save a big chunk when it comes to not having to pit in this particular situation. Harvesting residue is a challenge. Soil texture is also another problem with this system. Slope limitation is another challenge. During hot and drier times of the year, you may sometimes battle with mortality. But at this stage, because we plant in the winter season in the Zululand area, we've seen or noted this system as having the best results in terms of survival. And the new measure that's been introduced in the business, the issue of the uniformity at 3 months, it ranges best against the rest of the planting system. In terms of water usage, you're looking at about 1.5 to 2 liters of water per plant. Then also productivity-wise, you are able to get 3.3 plants per minute per person, of which it results to about 5.8 hectares per sheet. Next slide, please. Okay, looking at the productivity comparisons now of the 3 systems that we've looked at. Vasa Planter, we've got 2 colors there, you will see. We've got time study, work done by the research team, which is in blue. Then the other color, the one in gray, not blue, sorry, it's green. The one in gray, then it's the actual numbers that we get as operations now on the ground. You will see with the Vasa Planter, the research team has estimated around 5.2 hectares per shift of 6.5 productive machine hours. We are coming out at around 5.8. And the Vasa Planter, it sort of gets close to what you get with the semi-mechanized planting operation, which is at just over 6 hectares per shift. So the difference there, you spend time in pitting, and then also the other, you spend time pitting with the Vasa Planter, but with the semi-mechanized, you get to a pit that is already prepared, and your planting tube, it just slides in quicker and faster. Then your fast trap, it obviously does not, we just over 4 hectares per shift in terms of productivity. This system we mainly use on sites that we mainly use the system at the moment for your planting operations, but also where we do not have, where we find that we don't have capacity, we then deploy this particular system as well of the fast trap. Pitching, it's I won't say much, it's what you get with the Impedance per shift. It's about 2.9 hectares per shift, over 6.5 productive machine hours. Next slide, please. Okay, this is just a high-level comparison in terms of factors that one touched on, as far as benefits, as far as challenges for the different planting systems. But I've also included now the manual planting operation. Slope limitation, for example, you will see that only the manual operation in the Vasa Planter that are not much affected by the slope limitation. In terms of ergonomics, cost saving, and quality, you measure quite low with your manual planting. Harvesting residue, soil texture, not much of a problem, because with this one you do a pre-pitching. It's a labor-intensive operation, the manual operation as well. But looking at, in comparison to the Vasa Planter as well, Vasa Planter, it ticks green, it ticks positively in almost all the aspects, except the element of soil texture, which is a challenge when it comes to that. So that is basically what one was trying to sell with this particular slide. Next slide, please, Modern. Now, finally, this is just as the learning now of this improved planting system that we are running. What are some of the learnings that we've noted and we are focusing on? One thing that we've actually looked at, operational planning is very critical if you are running a modernized planting system. For example, you need to ensure that your access routes, they are clearly outlined. As you can see with the machine on the pictures on the right hand side, it's on the picture there, it's a M350, one of the de-stamping and mulching machines that was commissioned last year in the Zululand area. It helps us to open, as per the picture at the bottom, it helps us to open access for the machine. You need to plan ahead, ensure that your plans, they talk to each other. Availability of resources in terms of water, they have to be close. You can't have a situation, the operation is a high capital investment operation. You can't have a situation whereby you run out of water, or else your machine, your tractor machine needs to drive to a filling pond. You must have backup system close by to ensure that you've got enough water for the system to run constantly. Plants, in terms of plants, it's not only about the quantity or availability of plants, we also look at quality. I think Heinz touched on that quite nicely, looking at the quality, how straight are the plants, because with this system that we are running, if your plants, they are not straight, they may slow down your operation. backup spares, with it being sort of a semi-mechanized operation, the machines, they break every now and again, and you need backup close by. You must have mechanics to readily attend to a breakdown so that you can ensure that you keep the system running all the time. In terms of ergonomics and improvement, steel bending, for example, is one of the issues or challenges that we were trying to answer with the modernization, as I outlined earlier. That one is eliminated. There's less handling of heavy materials as well. Then with ergonomics as well, the other thing that on one research that we're looking at, Nonku was part of that, we're in the same team with Nonku. We were looking at shift design, of which it also comes into the element of ergonomics. At the end of the day, the conclusion that we made as a team is that people are the heartbeat of operational excellence. For your operations to actually succeed and for you to be able to achieve the benefit of modernizing your operations, you need to look after your people, of which it talks to economics. It talks to ensuring that your teams, they are well trained, and the working conditions there are decent as well to keep the team motivated. Consistent quality achieved with consistent training, obviously. Like I said earlier, training, looking after your team, make sure that your team is trained so that you are able to achieve better results and survival. Low planting percentages are indicated earlier that with the planting percentages, you get to a compartment at times, you only have about 2 or 3% to plant because of these improved systems that we've introduced or deployed into the operation. Productivity improvements in operations, there's less labor, it's less labor intensive, and the guys are able to get more even though you've got less people deployed in your operations. The plant quality has direct impact on the productivity. Like I said earlier, with the operational planning, you have to ensure that your plant quality is actually up to spec, and your plant, you are able to achieve the targeted pace and productivity at the end of the day. Extended working hours. There is also a benefit of extending working hours with these new systems. You are able to run a 2-shift system at times, so that you can achieve more with this system because you are working with machines. It's possible with your distamping machines. It's also possible with your pitting machines as well. So the systems, they allow you to run multiple shifts with regards to this. I think I've reached the end of my presentation. Thank you very much for the opportunity. That was just me. Thank you.
Thanks, Wandile, for the presentation, and as expected, very practical, very technical, and I hope that it was of benefit to our attendees. So we are now going to move on to our Q&A session, and I'll perhaps ask our presenters to maybe just have your cameras ready. Then we will work through some of the questions, and you can then respond to the relevant questions that I will be asking. Firstly, there's just one question which is inquiring about if presentation will be made available. And yes, we will make this available based on the permission of the presenters, and we will then share a link where you can be able to access them. If you are looking for a specific one, you can then contact me and I'll be able to assist with that. Then one attendee here, Anonymous, says, not a question, but an observation. So it's interesting to see that other countries do not plant with water or hydrogel. Very interesting presentation, Heinz. Thank you. And then we also have a question here for Nonku. Nonku, it says, it's from Toby. Thank you, Nonku. Succinct and clear presentation. Would you be able to highlight or recommend guidelines for companies to adhere to when considering implementing ergonomics risk interventions and the cost of implementation? Where do we draw the line? Nonku, are you able to respond to that?
Can you hear me?
Yes, I can hear you, but your camera is not on. If you can put it on, please.
Cool. Perfect. So with regards to putting in place ergonomics interventions and doing cost benefit analysis, the first thing that needs to be done obviously is a what I call is a hierarchy or classifying your ergonomics risk, looking at what are your high risk areas. So this can only be done in a form of an assessment, and once one has those, one is able to do a looking at where the high risks are, and that's where the focus is with regards to interventions. And with regards to cost benefits analysis and putting together that's quite difficult with ergonomics, because the human component of or the health improvement component of the benefits of ergonomics is quite hard to determine instantly, whereas the productivity benefits and all that one is able to easily calculate and determine. So what I would advise is, as a guideline, is almost look at your high risk areas where there's a high risk of injury, and also that can be told by your safety tracking. Where are you having the most injuries? Where are you having the most back pains or employees that are complaining about your back pain? And then moving towards putting together your cost, your interventions, and playing around the cost benefits analysis between the two. Yeah, thanks.
All right, Nonku. There is also one more, actually two. The one says, how does the new ergonomics regulations change the way we apply ergonomics in the forest sector?
Okay, that's a nice question with the legislation. So we recently got the ergonomics legislation recently got promulgated, meaning that it is part of now the Occupational Health and Safety Act, meaning that companies are now have to comply. What does it change with the forestry sector? Basically, what it changes is that companies are now required to show that they are doing ergonomics assessments, or they are measuring the risk of the ergonomics risk of each activity, and putting in place the necessary interventions to reduce the ergonomics risk. These risk interventions may be engineering, administrative, or PPE. And also there's a big focus on the legislation with training and awareness. So doing a lot of training on ergonomics, making sure that the person working in any work environment is able to identify ergonomics risks and able to put in place themselves interventions. So it's a lot of training and a lot of risk assessments and interventions with regards to that.
All right. Thanks for your response with that one. And then the last one, Nonku, then I will leave you alone. I have one question for Nonku. Very interesting to see the role Mondi is playing to limit the physical stress on human. What are the plans in reducing cognitive risks of the silvicultural operations?
Okay, thank you for that one.
You unmute, Nonku. If you can just unmute.
Thank you. Oh, there we go. Am I off mute? So the first one that we've done as Wandi is we've done machine assessments of machines using the Swedish National Institute checklist. So most of our equipment goes through the checklist, checking whether seats are put in place in the right place, and looking at what are the risks around the machine cab. So focusing more a lot if there's a piece of equipment that has a machine cab, focusing on the ergonomics risk around that. But also we also have a big focus now. We're starting to drive the focus on fatigue management, putting in place strategies of awareness in order for the drivers and the operators with regards to fatigue management. And there's a lot of work that's been done by the wellness department to also assist drivers to be able to manage their fatigue levels. Yeah.
Okay, thanks, Nonku, again for your responses. I'm just going to take this one to Heinz, if you can just get ready. And it says, greetings to the house at large. I've got two questions based on the first presentation. The box handling method of seedlings in nurseries to field, does it also apply to eucalyptus species or only to pine species? And what is the stats of survival rate, deformities, or storing seedlings in boxes with limited light for photosynthesis with reduced irrigation abilities of seedlings? And the second one says, what factors contribute or lead to the selection of the box seedling handling method over the plastic trays bucket? Hence, plastic trays buckets are reusable and only require one-time purchase. Heinz, over to you.
Long questions. Listen, you would have seen that the box, cardboard boxes are typically used in the Northern Hemisphere. And that's the main reason for that is to be able to close them off and to put them into cold storage over winter. That is most likely the main reason. You can't store plants in open crates in cold storage. They need to be protected. And that's obviously also to protect the seedlings inside in terms of moisture loss, etc. Yeah, the question was whether eucalyptus are being used in boxes. And excuse me, switched. So eucalyptus, no, we have not really. I've not really seen eucalyptus being packed in cardboard boxes. There was a test done in Indonesia a couple of years back, maybe about 10, 12 years back, where they tested plastic lined cardboard boxes. And they transported acacia, tropical acacia seedlings, and also eucalyptus in them. They did have a life, a limited period that they could stay in those boxes. You can imagine how hot Indonesia is. And I think the guys said 48 to 72 hours max in those boxes before they have to be planted. So yeah, in short, cardboard boxes used in the Northern Hemisphere for conifer seedlings, and we see more open plastic crates used in the Southern Hemisphere and tropics for pines and eucalyptus. I hope that answered both questions.
Thanks, Heinz. Thanks, Heinz. I think that covers it. Just another one here. It says a quite profound discussion. I'm not a scientist or forester for that matter, but cannot lose sight of how thought-provoking this is. Firstly, the passion and association of speakers in the field and the relation to the practice in their personal capacity interest in nursery and agriculture, even from the sustenance background. My question is, how do we then extend our knowledge to motivate the practice of planting and related to ensure that the interest is enticed to bridge the generational gap for foresters to take over the baton that was highlighted by Nonkululeko? Is any of your empirical studies and presentation published for aspiring scholars to reference with pride and apply the evolution to other practices to impact other sustainable development factors to preserve the environment and spark the economy and contribute to social development? Okay, so I'll just talk in terms of the availability of this information. Yes, the information will be made available over and above the recording, but maybe I will ask Luandile to talk about the process of bridging the divide between the current foresters and the younger ones to ensure that this information and knowledge is imparted on them. Luandile, you want to maybe just comment on that one?
Thank you, Modan, for the opportunity. I'm a strong believer that learning is in field. You can never learn behind a desk if you want to add value as a forester. So in terms of sharing of knowledge or passing knowledge to the newer generation of foresters, I think as much as at this stage we are faced with COVID, which has thrown in a curveball in many of the activities that we would normally partake into. We still need to see more and more field days, more and more opportunities or not per se, yeah, it may be opportunities or else projects given to the new generation of foresters, whereby they are given a platform to exercise and play around with ideas or else experiment things in bulk. As long as we still have that culture in the industry, the flow of information or sharing of information will forever reach the next and the next generation to come. So in summary, 12 days, it's what we need to partake on the most. Thank you.
Thanks, Luandile, for that response. There is a comment here by Andrew Morris, and he says, congratulations to the speakers on their clear and informative presentations this morning. It is great to have more exposure to the major trends in silviculture operations. I have one comment. Although improvements in work quality have been mentioned in the presentations, there have been few metrics that speak to this aspect. Any silvicultural system used for stand regeneration must achieve the same basic outcomes that will ensure continued long-term wood supply, as well as contain costs and improve the economics of the job. So thanks for that comment, Andrew. It's much appreciated, and I think it is quite true. We still need to ensure that the basic outcomes and the goals of wood sustainably supplied are achieved. We are now going to take a brief break, and I want to take this opportunity to thank the speakers from our first session who have shared their knowledge and information based on their expertise and for responding to the questions that were asked. We are going to take a short break and we will then come back. We want to start off. We are slightly behind time because we're supposed to be starting now, so about 15 minutes behind. So if we can maybe just grab a coffee, stretch our feet, and try and resume here at 12:15. So at 12:15, we will then move on to the second session, which will then start focusing on the international presentations, which will be given by Dr. Thomas Beck, Mr. Santiago, as well as Professor Saulo. They've joined, they are ready. So we will then resume at 12:15 and then proceed. Thanks to everyone. Well, good afternoon and welcome back again. We are now going to proceed with the second session. And as indicated and outlined, we will be looking at some of the international happenings around the world. And for this session, we'll be looking at Sweden. We'll also be looking at what is happening in Uruguay, and we'll also look at what is happening in Brazil. And this is important for us to remain abreast with the technological developments that are occurring not only in South Africa, but also globally, so that we can be able to learn and perhaps adopt some of the things that are happening globally. So to start off this second session, we have Dr. Thomas Beck, and he is going to be presenting on the topic of the status of mechanized planting in Sweden. And the background, Thomas, is he was born in 1978 in Sweden, and he grew up in Alberta in Canada. He studied forestry in British Columbia in Canada during the late 1990s and at SLU in the early 2000s. He studied economics and forestry for 1 year as an SLU exchange student in KZN in Pietermaritzburg, and that was during in 2004. In terms of work experience, Dr. Thomas Beck has been a manual tree planter and brush cutter in Canada during the 1990s, and he's also spent 4 years as a forest planner for Stora Enso in Sweden during the 2000s, and he was a doctoral student at the Södra Skog from 2009 to 2014. He's also been a guest scientist in forest operations at FP Innovations in Montreal in Quebec. That was in 2015 to 2016. today. He is a lecturer on forest operations and also does research in silviculture technology at SLU's School of Forest Management, and his personal interests are in forest ownership, orienteering, skiing, and he's also a father of 3 kids and were teenagers. So Dr. Thomas Beck, we're looking forward to your presentation, and he indicated that yesterday it was snowing in Sweden, so hopefully you're not too cold on that side. Over to you, Thomas.
No, thanks, Modani. No, I'm not too cold on this side because unlike the time when I was in South Africa, we have heating indoors. I've never been so cold in my life as when I was in South Africa indoors. Thanks, Modani. I'm sending to you now from mid-Sweden, and the topic is mechanized tree planting, though the status in Sweden. And you can see where Sweden is in relation to, well, at least Northern Africa there and on the globe. Thanks. I'm a senior lecturer at SLU in a town called Skinnskatteberg. And just as he mentioned, I do have some backgrounds in different parts of the world, and I do also have an understanding of your context in South Africa. The last bit of time in 2011, I was there at the Forest Engineering Conference in White River, and then we got to travel through Mpumalanga and KwaZulu-Natal. So I do have an understanding of your forestry in South Africa. So I will just start just to give you a bit of a context of what Sweden is like, just so that you can get an idea of how our machines, how they're evolving. In general, Sweden is either in nemoral or boreal forests. Boreal forests are in get myself a laser pointer here, in the north here, and the nemoral forests are in the south, and then the boreal nemoral forests are in the middle. In general, we have this 60 to 100-year-old rotation periods. So this is a picture from the nemoral zone, how the nemoral forests look, and this is how in the extreme north the boreal forests look. So most of the time the Swedish forests are somewhere in between, kind of looking like something like this. Typical forested landscapes in Sweden. Generally, we have most of our trees are either a pine, a Pinus sylvestris, Scots pine, or Norway spruce, Picea abies, and then we also have some birches, the betulas. And we do also have a couple % of our forests being exotic species, the Pinus contorta. It's from North America. So we do have a few % plantation of exotic species. So general Swedish forest ecology, we can sort of divide it into 3 parts. The star there is Skinnskatteberg, where I'm sort of based in at SLU. In southern Sweden, we have generally high site productivity, at least for from our perspective. We don't have generally snow, especially now with climate change, and we have a whole bunch of predation, either from insects or from different browsers. In the north, we have low site productivity and cold soils and reindeer. So there's a gradient, of course, and in the middle there we're a mix of the two. So why is the Swedish forest industry interested in mechanized tree planting? Well, it improves planting quality, tree planting quality, and this has been shown among things in my doctoral project. It also improves continuity among silvicultural workers. We have otherwise very many foreign workers doing our tree planting. It reduces also the threat of labor shortages, as that's been sort of overhanging threat for a long time in Swedish forestry. And because it improves planting quality, we have the opportunity to reduce regeneration costs. We haven't really got there yet, but it's on its way. Other advantages include reducing soil disturbance. Here you see a picture of a typical sort of a site preparation activity, disc trenching in Sweden. And that will disturb up to half of the soil area on a clear cut. And soil disturbance, of course, will bring with it things like different leaching of different minerals and such, and sedimentation. But if we use most of our tree planting machines today, we reduce the soil area disturbance, maybe half of it. It also requires fewer trees per hectare because we have better tree planting quality. So we reduce our target stocking rate, which we can save money. And there's also the potential for technological improvements. Sweden, we've had a long history of planting machines. There were machines that was like this Hiko that sort of was intermittently advancing, as we call it. We had the Silvanova. We had all kinds of various ones, semi-mechanized machines. We've had other crane-mounted devices. We've had machines that added soil. We've had also finished machines. So we've had and ever since the 60s, we've been trying out many different machines. Silvanova was the most successful machine. There was produced about more than 10 of those at least, and they worked. It was in function in almost 20 years. Today we have 4 to 5 machines. We don't have that many. Most of them are down south in Södra, and they are then exclusively bracket planters on tracked excavators. We also have one up in the north here. This was my old employer, Södra, and down here in the south, they're a bit more competitive. But since 2019 or spring 2020, we have this Plantmax. This is a modern version of the Silvanova, and this is the state-owned Sveaskog that's financing this planting machine. So and the big yellow star is sort of where it's operating. It's a forwarder-based disc trencher. So the disc trencher you can see here, and the planting arms there. So the question then is how is the planting quality of this machine? This was just a follow-up study that was done last October, but it's been published just now recently, and it showed that if you look at how the proportion of planted seedlings and how their adequacy or their quality class here, we're seeing that this machine plants poorer quality. There's more inadequately planted seedlings compared to manual tree planting. How these look, these different quality classes, well, a class 4 seedling could look like this. In this case, during the autumn, it was planting Pinus sylvestris. Class 3 would be when you're more into our deeper soil horizons. We want it to be just in humus or just in the leached horizon, and an inadequate seedling would be like this one. This here, the seedling was missed in the seedling feed. The seedling feeding system had missed the seedling, so it had fallen without getting planted. And this we can find in all of this can be found in a master thesis on the web here that was just published recently. Productivity, well, for Sweden, the productivity is interested in Sweden. We're interested in the adequately planted seedlings. So if we look on the y-axis here, we're looking at the number of adequately planted seedlings per productive hour. And that is, of course, a function of how many of the seedlings are adequately planted. The triangle here was sort of in this study, 76% were adequately. Well, we've been averaging around 1,200 seedlings per hour, so it's quite a productive machine. But if we can't raise the proportion of adequate seedlings, we're below 1,000, right? Because a lot of the seedlings are not being planted inadequately. So basically, there's a strife. We need, this machine needs to have some sensors so they can plant seedlings a bit more intelligently. So that's the next step for this machine. The machines, the arms are otherwise sort of just kind of randomly placing their seedlings. Seedling handling on the PlantMax. Well, here you can see a photo of how many seedling boxes one of these machines. Since it's highly productive, it uses a lot of seedlings. You open up each box is opened up, put into a storage rack. The storage rack is mounted with a crane onto the machine. The forwarder has a crane still. Then the operator grabs these cassettes or these boxes and feeds them onto conveyor belts on both sides to the arms, and then they are planted. The seedlings. Yeah, so you can see there's quite a lot of the problems sort of for the planting machines here in Sweden is just this seedling handling, or this seedling supply, or the seedling logistics, if we want to call it that. So we've been looking into this, myself and Skogforsk, which is the logging industry research institute here in Sweden, and we've been looking at different seedling packaging, and we got a study just in the midst of being published soon. And we've been looking at conventional packaging, these conventional boxes, as you saw, and also just sending in trays, versus, for example, machine-specific packaging, where we're seeing if we can load the seedlings in these boxes with these grid spacers. And we've been sort of looking at the total cost from a Swedish standpoint. And these cardboard boxes, where you would have this type of a cardboard box with compressible paper grids, would show some promise. So yeah, anyways, future development. Well, the crane-mounted planting devices. We're looking at basically hoping to improve them. Although right now, presently in Sweden and in Finland, most of the planting devices are concentrated towards the southern hemisphere. So I'm sure you've perhaps seen some of these photos. Vasa Planter for P12. We got M Planter. And Risotech. These are the Finnish machines. Some of the future development will be sensors, where we can also have them on these crane-mounted devices. We're looking to find sort of where the obstacles are on the ground. But at the same time, there's been some pretty interesting projects that have started in Sweden. For example, Skogforsk Autoplant project, where they're envisioning within 5 years of creating sort of a semi-autonomous machine that will be preparing the soil and planting. So you can look at on the web for this Autoplant project. And at the same time, my previous employer, Södra, I've been looking to produce a planting-only machine, a smaller machine that's just going to be also semi-autonomous. So they just started this, what they call Brasat, well-planted project. So we'll see where that comes out. But that's a pretty exciting project. Okay, lastly, here are some conclusions that can be drawn from mechanized planting in Sweden. There are still many technical opportunities to increase productivity while reducing the cost of planting machines, so there's still lots of opportunity out there. But this cost-efficient seedling supply, it's definitely challenging. It's something we're struggling with and have been struggling for a long time. The trend is generally towards smaller machines. You saw those big projects there from Skogforsk and Södra. They're looking to producing planting only machines, not having to do site. So yeah, that trend is there. And fourth, labor for manual tree planting is becoming scarcer, and this is increasing the interest in mechanized tree planting. Thanks.
Well, thanks so much, Thomas, for that informative presentation. Interesting things happening and going to happen in Sweden over the next couple of years. So we're looking forward to those developments. So we have just a reminder to everyone. I see there is some questions coming through in the Q&A. So if you do have some questions, please pop them under the Q&A session, and at the end of our presentations, we will then tackle them all. So moving on, we are now going to go to the next presentation, and we have a presentation by Santiago Ferrando, and he will be presenting on the use of drones to effectively conduct silvicultural operations. And he's basically going to be focusing on drone technology development within silviculture with a focus on the Uruguayan experience. So just a little bit about Santiago. He says, I'm an engineer in agronomy, specialized in forest with a master's degree in data science. I have an experience of 12 years working in forestry companies here in Uruguay, in silviculture and research and development areas. In 2018, I created a consultancy company, Fernando and Associates, with focus in technology and data science applied in the forestry industry. Last year, with a partner, we started another company called Sky Services Uruguay, which offers AUV services with focus in pulverization, which is weed control, and spreading, mainly responsible for end control, and technical support in drone technology. From 2017, I have been a professor at the University of the Republic in the Silviculture and Quality Control Department of Forestry in the faculty here in Uruguay. Nowadays, my principal interest is in artificial intelligence applied in forestry operations. Fortunately, we are developing some projects in this field with some companies here in South America. So, Santiago, we're looking forward to your presentation this afternoon. I know that the time differences exist, but we are glad that you are awake and ready to present for us. Over to you, Santiago.
Thank you very much, Medani, for your presentation. Good morning, everyone. Thank you very much for being at this conference on the use of drone technology in the Uruguayan forestry sector. Before I start talking about technology, Medani did a good presentation of me, but I want to talk about me. My name is Santiago Ferrando. Bueno, Modani told that I am an agronomist, but I want to present my country, Uruguay. Uruguay is here. It's in South America, between two giants such as Argentina and Brazil. Uruguay, it's a country recognized in the world for forestry production, livestock production, the software industry, and for soccer. South Africa brings great memories to the Uruguayan as we came out fourth in the World Cup that was played there. I okay. Today's conference will be focused on three main ideas. The first one will be to briefly tell you about the experience developed with drone technology. Sorry, in the Uruguayan forestry sector. The second will focus on the keys to select which type of technology is the best for silviculture. And the third one is how we can make this implementation successful. First of all, I want to talk about our forestry sector in Uruguay, because our sector had a significant development in the last decades. The forested area has risen from around 200,000 hectares in the early 1990s to just over 1 million hectares today. Timber extraction has multiplied by 5 in the last 20 years, reaching 17 million cubic meters nowadays. Most of our production is focused on pulp mill. And nowadays in Uruguay we have 2 pulp mills, but next year we are hoping to open another pulp mill here in Uruguay. Okay, the first topic that I will talk is about the Uruguayan experience. From our beginning to date, we have more than 8,000 hectares work with control and uncontrolled. Drone technology was designed thinking that the same drone can apply both solids and liquids. Only changing the tank of the drone, you can do that. Now, moving on the most common scenarios in Uruguay, I'm going to present the 2 scenarios where drones are doing a good job. At the left, you see the first scenario is the control of eucalyptus regrowth. Today in Uruguay, most of the companies are planting eucalyptus clones. So we are changing genetic materials, which makes it necessary to control regrowth with herbicides. In these situations, the use of tractors or people is not very convenient in these situations. So drones are doing better jobs. In cases like this, today we are flying 2 meters from the target, approximately 3-4 meters from the ground we are flying. The dosage that we are applying is between 15 to 20 liters per hectare, but we are looking to go down between 7 to 10 liters using only chemical products without using water. We have seen more. We have seen some papers in research that indicate that applying more concentrated products, we can reduce chemical doses and have better weed control. At the same time, we discovered nanotechnology. Nanotechnology it's very important because allows us to obtain more friendly chemical products for drones, because the particles are very smaller, and it's very important for drone technology. Another important point of nanotechnology is that present better stability when we are mixing 2 or 3 products in the same tank. Remember that drones has very small tanks, and the working speed in these cases depends on the terrain, obviously, but it's between 5 and 8 meters per second, the velocity of the drone working. We work with a pump pressure of very low, 1.5 bar, but we have the possibility to increment to 6 or 8 bar. And we use digit nodes like XR or TTI, depending basically on the wind speed. If we have the wind speed is high, we use TTI, and low wind speed, we use XR. In terms of active or the kind of herbicides, we are using a great variety depending on the company when we are working. Some companies prefer glyphosate with 2,4-D, some other companies prefer other kind of products. The operational performance of drones in this type of work is very good, reaching an average per drone of 20 to 25 hectares per day. The second situation on the right is uncontrolled. Spraying solids is much easier than spraying liquids and have less dependence on the weather. It's a very important point. In general, we are applying between 2 to 6 kilograms per hectare of fipronil. Fipronil is the uncontrolled chemical that we use here in Uruguay with excellent controls. The operational performance of drones is much higher in this case, reaching an average per drone of 40 to 50 hectares per day. Okay. Next, I'm going to show you some videos of the drones working in different situations in the field. Before watching the videos, as you can see in these photos, the areas assigned to work with drones are generally areas where access with other machinery or with people are very complex. Okay, if you see this photograph, for example, you see branches, trunks, it's very complex terrain. Okay, for example, okay. In this video, we are using the same, we are using a drone of 16 liters. This 16 liters drone is applying glyphosate in an area where there are harvest residuals, large trunks, branches. Another video. Okay, in this video, we are using the same drone, but if you see the drones automatically, it's flying automatically and copy the terrain because the drone has a radar which permits copying the terrain. Okay. In this one, you see a bigger drone, 25 meters, spreading fipronil for ant control. This area is clean, is ideal. I prefer that kind of area, but it's not easy to find it. And in this one, you see the same drone, 25 liters, spraying fungicides in a nursery, a big nursery. This nursery produces more than 20 millions of plants, of clones, eucalyptus per year. And we are testing the drone for fungicides. Okay. Another important point is to have support teams in the field to be able to quickly charge the drone, so that the team is always working. In our case, in general, we have 10 to 12 batteries charged by drone in the field. Okay. And in turn, we have a motor, if you see in the photo, to recharge the batteries in the field. In these photos, you see a support team for one drone, but we have another equipment. In this slide, the team can supply 3 drones working simultaneously without problems. We designed this team support with Carlos Harwich, my partner in Uruguay. In summary, from my point of view, there are many reasons to consider this technology for use in forestry. Drones could reduce labor costs, especially in situations of difficult mechanization. It's an important point. Drone is more efficient and economical than classical option. In quality, drones are very good and comparable to conventional systems. And by using less water and having the potential to reduce the amount of chemicals, this technology is very good in terms of environmental sustainability from my point of view. Besides all, by using less amount of people, we can reduce accidents levels and provide flexibility to service companies because it's easy to transport all the team. You only need a truck or a car and the possibility to transport the support team and do the job without problems. The next point is how to select the best drone for our situation. What happens to us today with cell phones, shoes, car, and drones, that's there are many options, which makes choosing the best options even more difficult from my point of view. In my case, when we started with this, I had to go to China and visit a lot of cities. I visit more than 5 different kind of cities and visit more than 9 factories to see what were the difference between them. And the most interesting, from my point of view, the most interesting thing was that rather than seeing difference, we saw similarities between all of them. Specifically, all of them are drone assemblers, nobody manufacturers. This is very important from my point of view because there are few brands of flight controllers, few brands of battery manufacturers, and all the companies use the same. In fact, I think that today you can buy the parts by yourself, for example, from Alibaba or another kind of websites, and assemble your own drone without major difficulties. Or you can make a phone call to China and the people make your drone with your name if you like it. This is from my point of view is very important because this was not the case a few years ago. No, but today is real. You can do it, and from in the near future, it was an important point to develop this industry from my point of view. This is some photos when I visit China with my partner, and I took some courses and visit a lot of office of assembled companies. To finish the presentation, I would like to give my opinion on what things are key to be successful in the implementation of the technology. The first one is to focus on jobs where mechanization is impossible or very difficult. The second thing is to generate human resources that want and have an interest in the use of this technology. In this time, we have learned that operating this type of drone is very different from operating image and video drones such as Mavic or Phantom drone. Having the possibility of carrying trials is another important point. Trials, tests, and making drone adaptation is another key point. We have tested different type of nodes, different flight heights, speeds, etc. In all cases, we have generated data to analyze what works and what does not work. Thanks to the data, we can explain the results and implement continuous improvement. To be successful in the use of drone technology, you have to define objectives for spraying, for the application of solids. It is necessary to be clear about which chemicals are compatible with ultra low volume and which chemicals and mixtures are not. Because remember, you are using a drone, you need ultra low volume. Finally, it is important to know that this technology still has many challenges ahead, and that implies improvements and adaptations that will arise with learning in the field. It's a big problem for me, but it's a challenge. Therefore, you must be prepared to change and improve all the time if you want to be successful in its use. To finish, I would like to mention a phrase that one of my mentors always tell me that I understand applies to this technology for our sector. When ideas come their time, no one can stop them. Thank you very much.
Thank you, Santiago, for the very informative presentation. I really quite enjoyed the way in which you described the details of drones and how they can be used and applied within our forestry industry. And you outlined clearly that there is good potential, but there's also challenges that we need to be aware of. So thank you so much for sharing that with us.
Thank you for you, Modani.
All right, so we are now going to move on to the final presentation, which will be from Professor Saulo Guerra, and he is going to be presenting on the current technology trends in silviculture operations in Brazil. Now, Professor Saulo was also involved in our presentations last year at our webinar, and he gave a good overall view of what was happening in Brazil. And this year he brings a unique twist about some of the developments which they've been monitoring over the past couple of years. So just to tell you some information about Prof. Saulo, he is a forest engineer, and he got his degree and also his master's, and he got his doctorate in 2006 from the agronomy from the College of Agricultural Sciences at Sao Paulo State University, also known as UNESP, and is the former director of the Foundation for Agriculture and Forestry Research, and also a former coordinator of the undergraduate course in forest engineering at UNESP. Is a professor in the Department of Rural Engineering and Socioeconomics at UNESP, a coordinator of agroforestry biomass and bioenergy laboratory, also known as LAB, and scientific head of the cooperative program on forest mechanization and automation at the Forestry Research Institute, that is IPEF. He's also the deputy coordinator of the International Union of Forest Research Organization, also known as IUFRO, which is the Division 3 Forest Operation, Engineering and Management. He is currently fulfilling the role of being the director of the UNESP Innovation Agency, which is quite a prominent organization involved with a lot of developments across Brazil. So Prof. Saulo has been a colleague, and he has been a close associate with our institution. And I just want to say, Prof. Saulo, welcome, and we look forward to your presentation this afternoon about what is happening in Brazil. I'll hand over to you.
Thank you, Professor Mwedani. Can you hear me?
Yes, loud and clear.
Okay, can you see me as well?
Yes, I can see you as well.
And also, are you gonna be able to watch my presentation? Can you see the first slides?
Yes, I can see the first presentation, the slide showing.
Okay, so good morning to everybody, or good evening, or maybe good night to all of you. And thank you, Professor Mwedani, for this invitation. It's a pleasure to attend this meeting. It's early morning in Brazil, so unfortunately I was not able to see all the speakers at the beginning of this presentation, but I will catch them later on. So today, I'm going to talk a little bit about the Silviculture Mechanization Index Survey. This publication, this book was published 2 days ago, Mwedani. So for your audience, this is going to be the first international presentation. And we will show today the data collected during the 2020 and processed in 2021 here in Brazil. One of the things that I would like to highlight to you, all of you, is the citation of brands and models of the equipments does not indicate a recommendation by the author. So I will show you today some names, some models, and we are not recommending those machines and those equipments. All advertisements on the publication from the sponsoring companies do not have any influence on the results presented. They just provide funds for us to publish the book and to deliver the book for free for the forestry community. All the data I'm going to show you today were collected straight from the employed or collaborators of the company affiliated to our cooperative programs, the mechanization program and the Pine program, or those companies were associated to IPAF, that is the Forestry Research Institute. And the data compiled here reflect only the reality of the participating companies. So the authors of this job or this publication, it's me, gracefully presented by Professor Mwedani. Our executive coordinator is Dr. Guilherme Oguri, another professor, Mauro Schumacher, from the Federal University of Santa Maria. He worked with Pine. And two of my interns, Raul Aiello and Isabela Presotto, both from São Paulo State University. And what I'm going to show you today is the data collected inside those 20 forestry companies. And you can see here big companies like Suzano, Bracell, CMPC, Eldorado, and smaller units like Florestal Gateados or Juliana Florestal. So it doesn't matter if you have 1 million hectare of forest or 10 or 12,000 hectares. If you want to share your data, you will be with us. So the project itself is led by us here in São Paulo, Brazil, inside the cooperative program of forestry mechanization automation. We are doing this survey during the last actually 6 years, and 2 years ago we published the first survey, and from this unit we increased the representativeness of our data collection in 153%, and we added in our publication an English version. So you in South Africa, in Australia, in Sweden could read our publication, and also we included a new chapter adding the pine status in Brazil. Okay, so the data collection started with our files sent to the forestry companies individually. Then the companies or the contractors fill out the forms, and due to the pandemic, we did all on remote basis. The first version of our publication, we went to the field and we collected data on the go, but it was not possible last year. So with the data back in our office, we start to process the data and we deliver the first report for the forestry companies. And after their validation, we made a full report, individual full report, and sent back for each of those 20 forestry companies. Then, adding all together the 20 forestry companies, we came to this final survey and publication. And what we share here, we share 5 main topics. We identify the forestry companies and will provide the human resources information, the mechanized resources, the implements, and finally the mechanization level. But due to the time we have here today, I will not show all the data, and I will invite you to download the publication later on at the end of this seminar. So the first important information is that we collect more than 50% of the total Brazilian planted area. Right now, we could find that 45% of the eucalypt plantation is located in the southeast of Brazil, but you can still find eucalypt in the south, middle east, and northeast of our country. But it didn't happen for the pine plantation. The pine plantation only happens on the south region of our country due to the climate conditions and due to the local culture. Talking about and give you a taste of the human resources, 50% of the total Brazil employs close to 15,000 people in the silviculture account. I'm not talking about the harvesting operation. I'm not talking about the corporative staffs. I'm talking only with coordinators, supervisors, field leaders, operators, and so on for silviculture actions. And 46% of the total people involved has formal links to the forestry companies. The rest of 54%, they are connected with the contractors or their own enterprises. And you can see a wide differences inside each company. You can move, for example, from 81% of the laborers working with machine operations in each company, or you can go down to 5%. So you can have an overview. Which company is working with their own fleet and which company is renting or contracting machines to run silviculture operations. Our fleet right now for silviculture actions has only 2,500 tractors, and 33% of those tractors belongs to the forestry company. But only 3 forestry companies pursue their own fleet, so they don't have contractors. The other 17 companies, they do have contractors or service providers to work in silviculture for eucalypt and pine. So if you take a look on the manufacturers working in Brazil right now, we can track 32 different manufacturers, tractor manufacturers, and they are offering to us close to 200 different models of tractors. And 72% of this fleet belongs only to 3 manufacturers. And if we go a little bit further on this analysis, you can see that 4 companies, they have close to 80% or even more than 80% of the Brazilian market. And some other manufacturers like Carraro and El Green, they pursue or they offer just one model and sometimes just one unit for operation in Brazil. So this top, maybe top 10 or top 12 can represent the large majority of tractor manufacturers down here. In terms of the mechanized resources, I brought to you the rate of tractor use for our companies. And if you take a look on this number, the average index is close to 9. And this is not a recommendation of mechanization resource in terms of tractor usage. It means that most of the companies, or the average of the companies, are using 9 tractors per 10,000 hectares. So using this rate, you are not able to identify the forestry company due to its size, the planted size area. So you can see some companies, they have a great number of tractors on the go, like 24, 18 tractors for 10,000 hectares, and some other companies just quite few units. That could indicate, for example, in this case, the Q forestry company, they are not so mechanized, or they are very efficient. However, on the other side, 24 tractor means they are very technified, or the efficiency of their machines are not very good. So you have to understand, and you have to read all the publication to get your own conclusion about the tractor and also about the implement rate. Again, we have the same methodology. We share the implement rate, and in this case, it's going to be close to 16 implements per 10,000 hectares. And if you go back again to the Q company, you see very small numbers. So it seems to me that this company does not have mechanization inside silviculture operation. And the S company, that was a great number for tractor rate, still has a huge number of implement rates. So it seems to me that this company, the S forestry company, really have a lot of mechanization in silviculture operation. And one of the things that is it's beautiful somehow for our forestry sector is that we have close to 4.4 thousand implements on the go, but they came from 137 manufacturers, from international manufacturers, local industry, and also from very tiny garages where they are assembling tools to make our silviculture works. So 9 forestry companies, they use implements from service providers, but in the other hand, 7 companies, they have their own implement sets. So it's quite half and half. It's almost half and half in terms of utilization from service providers and own resources. So I'm talking about right now a little bit about the mechanization level. So I will show you the data from 4 different groups of operation. We divide the mechanization level in 4 different groups: manual, semi-mechanized, mechanized, and automatic operation. The manual operation is split into levels, level 1 and 2, and level 1 means that the human power is prevalential. However, we don't have any mechanical actuation. So I'm talking about whole axles or manual planting. The level 2 means some mechanical actuation, as for example the seedling transplanter or a bait applicator. On the second group, we go for the semi-mechanized operations, where we have assemblies or equipments that could be split in level 3, driven by a motor, like a chainsaw or a tiller, or even on level 4, where you can have a tractor and an implement, one driver and another external person working on the equipment, like a continuous planter or a conventional irrigator device. On the group 3, we have the mechanized operation, and this is quite important for heavy duty tools or tasks, where we have the level 5, where we have the machine, the tractor, and the implement without any GPS or light bar function. So we are talking about the basic subsoiling operation, for instance. And on the levels, at the level 6, we have special subsoilers or operations with autopilot functions or light bar functions. And at the very end, the 4th grade means or reflect the automatic operation, and again split it into levels. And the level 7, we are showing the mechanical assemblies which are remotely controlled by an operator in the field. They must be close to the area, like when we are spraying herbicide with drones, like our colleague in Uruguay just showed to us. Or it could be at the level 8 on autonomous mode, where we don't need to have an operator on the go. So we have planters or tractors on autonomous mode, driven remotely from the area, or even without any human interference. So considering those levels of mechanization, I brought to you here the 4 different groups: manual, semi-mechanized, mechanized, and automatic. And I show 3 operations only on this presentation. If you go for the eucalypt area, and if you're going to talk about the soil preparation, you're going to see that in 2018, 75% of the total worked area was on level 5. And this year, 85% of the area was worked with level 5 mechanization, and we are moving to level 6. On the other hand, if you go for planting operation, most of the planted area was done manually. So we still have humans working on planting operation. And for smaller companies, we went back for tools without any mechanical assistance. And today, due to the climate change, irrigation became more visible, and the companies are moving their operations to the mechanization level number 4, and certainly on the following years we will push the irrigation operations to the mechanized group. So on an overall view, the general mechanization level from 2018 to 2020 has a slight decrease in level 5, but that was a good information because we move up to level 6 and we also started to have real operations at level 7 in the general mechanization level. So you can follow right now what is going on in Brazil in terms of the mechanization level in silviculture for eucalypts. Right now, I would like to highlight the pine situation, and for the first time, we were able to deliver this data to the audience. And again, we are comparing soil preparation and planting. And here we have a very good overview in terms of the mechanization for soil preparation. All the companies evaluated, they have mechanization level 5 and 6 for soil preparation. And again, the planting scenario is a little bit worse than for eucalypt plantation. 45, 46% of the planting is still manual and without any mechanical assembly to help the labor on the ground. And if you see the weed control, and I brought just another example, we are very at the bottom of the mechanization level that push the pine general mechanization level to the bottom of our index. They are on the level 2. So to compare right now in Brazil, pine and eucalypt that are the most proeminent crops for forest plantation, eucalypt right now reach the level 5, so it's mechanized. And for the pine forestry companies, we are still on the manual level, level number 2. So Professor Muedani and the audience, I would like to thank the staff that was with us for this publication, and I'm showing their names and their companies on this slide. And also, we would like to thank our sponsors that make this publication available and free of charge for you everywhere you are. So thank you, Professor Muedani. Our cooperative program is very happy to bring this very fresh and updated information to your audience. And please take a look here on this website, and you are invited to download for free the publication, and you can collect all the details from our silviculture mechanization index survey in Brazil. So I give you the hand, Muedani. Thank you for the opportunity, and I hope I did the presentation sharp and did not take more time than you expected.
Thanks, Prof. Saulo. You did it sharp. That's good and really interesting information that you shared, and a lot of work in terms of monitoring what is happening between the recent past. And thank you for sharing this latest information, which you have just recently published. We're just going to take some questions, and I don't see anything that has come out in the chat. But perhaps for you, Santiago, just a question to find out what are the main specific drivers for the use of drones in Uruguay? Is there a specific reason why you see a trend of people wanting to to explore the use of drones in Uruguay as compared to maybe using conventional spray systems or just using tractors?
I don't understand the question, but can you explain me more?
Oh,
What
okay.
do
I
you
was just
want?
saying, okay, is there specific reasons why you see that there is an interest in the use of drones?
Well, okay, it's more easy to operate. You need, for example, one drone. Imagine now a drone make 70 or 80 hectares per day for ant control. You need only one operator and one drone. But if you want to do with people, you need 10 people to do the same job, but not the same, less hectares per day. And that's the reason, from my point of view. You need less people. For example, after you do the ant control, you have a map, and you see, okay, do that area, you know how many kilograms per hectare exactly you apply, and it's the companies like this kind of services, prefer that. And you know that the drone goes to the ground and do the job. You know, the starts at 8 a.m. and finish 4 p.m. and you have all the flights, all the information, and finally the cost is lower, no, lower cost, and a lot of information. From my point of view, there are some advantages in this kind of operation, no? And in some terrain, difficult terrain, for example, that is not possible to do with tractors, the drones has an advantage.
Well, thank you for that response, Santiago. Prof. Saulo, maybe just a question from you. In your perspective, and looking at the trends in Brazil, if you look at the future, where do you think most of the development would be more focused on? In terms of, you looked at soil preparation, the planting, and some of the tending activities, where do you forecast or see a lot more development happening, let's say, in the near future, in terms of from manufacturers' perspective and what companies are looking for in Brazil?
Planters, irrigators, and drones.
Okay, all right. Planters, irrigators, and drones for the future. Thanks. All right. Now, I just want to bring our session to a close. At the moment, I just want to take this opportunity and thank all the speakers that were involved in both the first session and the second session. We began by listening to Heinz, who gave us an overall view of what is happening in terms of nurseries, that transition between the nursery and the field. And he gave us perspectives from across different countries such as Sweden, Finland, Chile, Brazil, Argentina, and the United States. And that gave us a good understanding of the importance and some of the technologies that are being used in terms of nurseries to improve the compatibility between what the plants that are produced and the planters and technologies that we are using. Then Lishan then gave us a perspective of how mulches are now being used within the forestry industry, and he looked at their relationship with the planting, productivity, and the costs of the using mulches, as well as some of the amount of carbon emissions. So an interesting research, which I think lays a good foundation for future studies that will be done in this area. Perhaps in the future, we can also integrate this and start looking at the issue of plant survival, growth, as well as uniformity that comes from mulch stands compared to the conventional way of doing things. But overall, an outstanding research. Nonku also then came and gave us an overall view in terms of the ergonomics, what is happening in the silvicultural side, and she clearly outlined some of the ergonomic interventions that Mondi has been putting in place in order to improve the way in which silvicultural activities are done, and she clearly indicated some of the safety improvements. And I think overall an informative presentation which gives us an indication of the direction wherein we need to focus going into the future in terms of ergonomics and the activities that we have, especially with the new technology that we are now introducing. Lwandile gave us another interesting view in terms of planting, wherein he clearly described the transition that we have followed from manual activities to now more tractor-towed systems which are being applied in the Zululand area, technologies such as the Fast Trap and the Vasa Planter, and how they are being used effectively, as well as describing their productivities and their applications. And that was a nice, interesting first session. In the second session, we went international. And this is where now we had presentations by Thomas, who gave us an overall view of what is happening in Sweden, some of the technologies that were tried, and some of the newer technologies such as the Plasma X, and some of the innovations that are going to be taking place in the next couple of years. So something to look out for in terms of what is happening in the European side of things. Santiago then came and gave us the overall view in terms of the application and the use of drones for weeding and tending activities, as well as end control. And he gave us a good context in terms of where the opportunities are, as well as the challenges that exist in terms of the use of drones. And quite interestingly, what you indicated was the issue of yes, most drones you basically assemble, but the basic working components are basically the same, and you can be able to put them together virtually yourself if you have the knowledge. And then lastly, we had a good overall view from Prof. Saulo, giving us a good indication of what is happening in Brazil and the status thereof, with a good and unique comparison between what happened in 2018 as well as the recent happenings in 2020. And we're looking forward to perhaps further studies and being able to do comparative studies to see what is happening compared to Brazil with other countries as well. And please carry on with the work, and hopefully we can collaborate with other countries as well. So lastly, I want to just thank Melissa for taking the opportunity and representing our campus principal in giving the opening address. But more importantly, I also want to give a gratitude and thank you to our presenters that have taken the time out to prepare their presentations and their willingness to share their knowledge and information with not just within the organization, but the wider community. And I also just want to thank their organizations that they work for that have been supportive and given them the permission to be able to share this information in this webinar. So please send our gratitude for that. I would also want to thank the participants and the attendees that have RSVP'd and have joined us from the very beginning of this webinar, who were quite involved and shared some questions and inquiries based on the presentations that were given. Thank you for your involvement, and thank you for joining us. This webinar is only possible when there's interest and there's willingness to be able to hear about what is happening both locally and internationally. I also want to take a moment to thank Tiffany, who has been the cornerstone of our IT from the very beginning. Yes, we had some close call moments where we were getting a bit worried with some of the technical glitches, but thanks, Tiffany, for the support and being able to facilitate the whole session from an IT perspective. Your help is much appreciated. I also just want to take the opportunity to thank Melissa as well as Monica from the marketing side, who have been involved in developing a lot of the program branding side of things from the university. Then I would like to thank Posi Sadlokweni, and that's my MSc student, who was also involved in the organizing of the event and played a very important role in facilitating this webinar taking place. So in terms of the presentations, we will be communicating with the presenters to be able to share some of the presentations that have been made here on the NMMU website. And if you are interested, feel free to communicate with me and I'll be able to share the link where you can be able to access them. We are now already in the process of planning next year's webinar, which we have tentatively scheduled for the 19th of October 2022. So you will receive further details about the plannings regarding this webinar in due course. And lastly, I just want to say, if you have any suggestions on how we can improve the webinar offering, or if you have specific topics of interest that you would like us to focus on in the coming year, feel free to communicate with me, write me an email, and we will gladly consider that for inclusion in next year's webinar. In finality, thank you to everyone for participating and for your involvement, and we look forward to contributing to our industry. Our industry requires us to share information. Our industry requires us to be able to be innovative and to be able to adopt technologies which will be able to improve our efficiency. We do understand that we've got competition from various industries, but how our industry is able to remain at the top and sustainable is when we adopt and we continue to improve the way in which we do things. So in finality, I just want to say thank you, and we appreciate your support, and may you have a good day further in everything that you do. Thank you and bye-bye.